Okay, good morning, everyone. Welcome back to day two. Hopefully you can hear me okay. Thumbs up if you have any. All right, thank you, Gene. Perfect. Okay, so today we're going to be getting into a little bit more of the detail with some of the research and some of the industry projects that we've done. So stay tuned for that. We have a couple little technical issues we're dealing with as far as getting some of the presentations. So I'm going to try and, in the background, work through that a little bit. I'm going to turn it over to Brendan to give us a little bit of context for the day of what we're going to be doing. So over to Brendan.
Excellent. Thanks, Alan. Can everybody hear me okay? All right, great. So welcome to day two. It's a new day, new agenda, new format. I want to thank everybody for coming back today. Thank you for your participation in this event and for your willingness to try something new. I think yesterday we had a couple of glitches, but overall, I think it was a pretty successful event, seeing as we've never done anything this scale virtually before, at least for my team. Our team put a lot of thought into how to create opportunities for engagement and awareness. And I talked a lot about that yesterday in my introductory remarks. It's not ever going to be the same as it is in person, but I think it's going quite well. I think we're making the best of it. I think we're going to make some connections, create those opportunities for engagement. But I want to remind you that this is your event. Those engagement opportunities aren't going to go anywhere if you don't let us know how we can help facilitate them. So being that it's your program, being that you're here to learn about what we're doing, to make those connections, let us know if there's a way that we can facilitate that connection. We can unmute you. We can put you in a separate breakout room with somebody you want to talk to. We can help you exchange contact information. There's a number of different tools that we have that are a little bit different than being able to walk across the venue and shake hands with somebody and trade business cards. So just let us know if there's any way that we can facilitate that. Like Alan said, we got the chat going. We're monitoring that. I think the format today isn't going to allow for us to allow you to unmute yourself except during question and answer periods, just because we've got so many people and don't want you all talking over each other. Okay, I think that's all the kind of admin stuff. So on to the program today. Yesterday was about the strategy and the plan. We had several senior level Navy executives talking to us about the vision of the Navy for technology, how technology fits into meeting operational needs and creating enabling and force multiplying capabilities for the warfighter, but also through the Coastal Trident program that's aligned for port and maritime security community at large, which is obviously bigger, a bigger consortium, if you will, of partners than just the Navy. So today, it's about the action. It's what did we do with that vision? What did we do with that strategy and the plan? And how did we structure a program to meet that intent, to meet those objectives? And what do we actually do? So this would be the part of the event that you would go and you'd walk around and you'd see static and kinetic displays and you'd talk to people, you'd shake hands, you'd trade business cards, and you'd talk to them about their projects, what they were trying to do, what they ended up doing, what they learned, and what their vision is for the future. What's the next step? We've put together a program that has two different tracks, a research track and a Coastal Trident track. And we think that while we can't talk about all the different projects that we executed on the research side and on the ANTX and Coastal Trident side, we did try to put together a sampling of, that would give you a really good impression of the kinds of things we were doing. And, we think these projects are very interesting. They're intriguing. They have pretty broad applications. And so it should be a good sampling and, start kind of setting the seeds and creating those opportunities for engagement that I think we're all here looking for. So I said there's two tracks. If you look at the agenda, there's a research track and a Coastal Trident track. The research track is focused on research, obviously. These projects are all collaborations between the Navy and university research groups to develop technology that's relevant to naval operational needs. I talked yesterday about how the Navy has a robust infrastructure for research and development, for science and technology, and there's a very broad infrastructure and group of partners at the federal, state, local levels, private sector, academia, that are helping the Navy through programs like Alan's going to talk to you in a little bit, and programs like Coastal Trident to develop the technology that's going to go into the systems that we're going to take out into the field. So these research projects are all part of that infrastructure. These projects are going to be distinctly different than those we're going to talk about in track 2 because they're not operational systems yet. They're research into the technologies that are eventually going to go into those systems. And from my perspective as the Coastal Trident principal investigator, these are technologies that I really want to keep an eye on and start thinking about where they might be applied and how they might be implemented, so that I eventually will have a pipeline of systems to go take out in the field and test. So that's track 1. Track 2, the second track, is the ANTX Coastal Trident track. And then we're going to talk, like I said, about a number of different projects that we executed during the ANTX Coastal Trident program. So obviously I can't talk about all 32 or the rest of them that didn't get canceled. I talked yesterday about how we have 32 total projects in the ANTX Coastal Trident program, and only 11 had to cancel or postpone altogether. So we're going to talk about some of those. But again, this is intended to kind of spark engagement opportunities. It's intended to connect you with the people who are doing projects, see how you might collaborate with them, ask them questions that are relevant to projects you're working on. Maybe you're from a government agency and looking to procure some of these systems. If you need contact information, if you need to connect with those people, let us know how we can best facilitate that. So again, this is the part of the event where you would all be walking around talking to people. So we're going to try to do the best we can to convey that information that you would be talking to those people about, and then allow at the end, a time for you to plug in however you want to. And again, we have some tools. They're a little bit non-traditional. They're virtual, but we're going to do the best we can, and I'm pretty encouraged by it. So, Alan, if you're ready, back to you.
Excellent. Okay, thank you, Brendan, and a big thank you to our speakers and our participants today. Just kind of echoing what Brendan said, but then also for the time to come and share what your research has been and what technologies you've experimented with. So I'm just going to take just a minute and talk to you guys about the different research and university engagement programs that the Navy has. These are programs that have existed for a number of years. What we're trying to do this year and as we go forward, and we really appreciate your input and feedback as to how we can do this better, but really trying to align a lot of these activities and help to ensure that, like Brendan said, they're in a track and they're moving along, and we're able to support the progression of those as they transition from an idea, from a basic research level to an applied research, so where you can experiment, test, and ultimately, like we talked about yesterday, right, providing a capability out to the fleet and the warfighter. So one of actually two of the engagement projects that we're sharing today are both the NEEC, Naval Engineering Education Consortium program. That's a program that the Navy has across the warfare centers. We do about $500,000 a year in essentially grant research, where we put out topics on a broad area announcement, and universities can apply for those, and then they are provided that funding, and then they go off and they do that research. It's kind of twofold in what we're trying to seek from the Navy perspective. One is obviously we provide the research topics. So these are topics that we're interested in that maybe are beyond what we can do or the expertise that we have internal to our lab. And so being able to find the cutting edge research and those professors that are doing that research and be able to kind of help steer that in a certain direction that maybe has a naval application. And then the second part of that is actually being able to work with the professors and with their students, because it's a great way for us to start to develop those relationships with the university through the professors, and to be able to get in and find those students who are not only interested in the topic and interested in what the Navy's doing, but also for us to be able to find those brightest students and hopefully recruit them when they graduate to come work with us. And so we've done this program for a number of years. It's been very successful. We've hired some really great students from these programs. and we're really excited to continue doing that. So a couple of the professors that we're going to be talking with here coming up are part of that NEEC program. Actually, Ryan Nguyen is a student, is a NEEC student who's been doing research and working on his PhD that joined us this summer as an intern, virtual intern. Then the other program is our university research engagement program. And that's through the Office of Naval Research. And what that is similar where we can kind of provide some broad area topics, and then university professors from across the country can apply and actually come work for us, with us, for a 10-week period of time doing research, align research to what they're doing, their expertise, but then again, providing a way to sort of provide some perspective on maybe possible naval applications to the research. So again, just both these programs are a great way to build a relationship between the Navy and the universities for the research, for the relationships, and for the students that hopefully will be interested in coming to work with us. So we got a couple great speakers lined up here. I think we're going to kick it off with Dr. Jason Isaacs from Cal State University Channel Islands. Jason has been a longtime collaborator with us, but joined us this summer formally under the ONR Summer Faculty Program. So I won't steal any of your thunder, Jason. I'll let you kind of introduce yourself and please, your thoughts on the program. And then obviously we're very interested in your research. So I'm going to try and screen share your presentation and just go ahead and, tell me next when you're ready for me to push the button there. And I just need, there we go, perfect.
Okay, hi, good morning, everybody. Thank you, Alan, for the introduction, and thank you to the organizers of this event. It's something I've known about for a few years now, the Coastal Trident Expo. I think I went to it very early on in my time at Channel Islands a few years ago with the ESRM group and Sean Anderson, just to tour around. But it's nice to be taking part in the event this year. So the title of my talk today is Autonomous Robotic Search. And this was work that I did over the summer as part of the ONR Summer Faculty Fellows Program under Alan's supervision. So thank you for being a great mentor over the summer, Alan. And I think I really learned a lot about the needs of the Navy, and it's helpful to hear as a researcher how our future, in the future, our research might be used. So it helps us kind of tune what we're working on. So I'm a professor here locally at Cal State University Channel Islands and in the computer science and mechatronics engineering programs. And the work that I'm going to be talking about today is work that I also work on in my professor role with our students, in particular the students of the mechatronics engineering program. And so the picture that you see at the bottom of the screen there is a map that we created using multiple robots of the inside of a nuclear reactor in Satsop, or Elma, Washington. It's called the Satsop Business Park. So it's a decommissioned nuclear reactor that was never actually taken online, so it's safe to go inside of, but it was a chance for us to conduct sort of real world tests of the algorithms that we're developing here. Okay, next, Alan. Okay, so any good professor should start their, their talk by acknowledging who does a lot of the work, and that's the students. So this is a picture of some of my research team at Cal State Channel Islands in the Autonomous Vehicle and Embedded Systems Lab. Some of those students traveled with me again to this event for the DARPA Subterranean Challenge up in Satsop, Washington. And this is a picture on the right of all the competitors at that competition. So we were competing against teams from MIT, JPL, Caltech, Berkeley, Carnegie Mellon, some of the top robotics schools in the country. So it was a great opportunity for me and for our students to get to go up there and see kind of how the big boys did it. And we actually, I think, held our own in the competition. So I was really proud of the work that our students did. Okay, thanks, Alan. Okay, so what are the goals of this research? Really, at my lab at Cal State Channel Islands, what I'm trying to do is to develop a fleet of autonomous ground and air vehicles for the purpose of autonomous mapping and then search of an unknown and complex environment. And so what we're looking at is being able to go into, say, a disaster scenario with vehicles that are equipped with sensors capable of creating brand new maps of the environment, because in a disaster scenario, existing floor plans, existing maps may not be valid anymore. So it's important to be able to send vehicles in capable of creating new maps, as well as equipped with cameras that are able to search and other sensors that are able to search for, say, signs of survivors and actually locate those survivors and transmit that back out to human first responders who might go in after the robots. So the vehicles have to be able to traverse variable terrain. They need to be able to communicate with each other and the base station, as well as doing the mapping and searching tasks. In terms of applications, these vehicles could be sent in to provide these initial maps and situational awareness for and search for signs of survivors. Okay, next down. So I'm going to try to play a couple short videos here of just some of the vehicles that we're developing at Channel Islands. So Alan, you might have to click one more time. So this was one of our first attempts at a robot that we actually bought off Craigslist, and we took all the parts out of it and rebuilt it with new sensors, new electronics, and strapped a laptop on it and started writing algorithms to guide it around the halls of our building at Cal State Channel Islands. And so this was one of the first kind of autonomous runs we did, where it's actually going around 90-degree corners and avoiding objects like the scanner there and tables and chairs. Okay, next, Alan. So yeah, so that was an off-the-shelf sort of robot that we purchased off Craigslist. Now the picture here is a robot that we're designing that's capable of traversing fairly extreme terrain without losing its center of mass and falling over. So if you click one more time, you'll see the climbing over the steps. And so it's a hinged robot that's hinged in the middle, and it's enables it to drive over rocks and things along those lines. The student who you can see in the background, you can just see his feet. His name is Hugo Quintero, and he's actually a third-year mechatronics engineering student who this summer did an internship at the Naval base. And I talked to him a couple days ago, and he's going to continue working there during his break. So over the winter break and then the following summer break. So I'm really happy to see this connection among my students in my research group now transitioning to employment with the Navy. Next, please. And then this is another robot that we've just purchased a kit of this robot. And the cool thing about this one is it's capable of climbing stairs. So in our previous version of the competition where we were at the DARPA Subterranean Challenge, we were limited in that we didn't have any robots capable of climbing stairs. So after that competition, we went out and purchased a kit. And so one of our students, Michelle Balick, actually, we shipped the kit to her house over the summer, and she spent the summer building the kit and equipping this robot now with sensors, and now it's capable of driving autonomously. So this was an early video of it just climbing the stairs remotely. Okay, thank you. So that gives you a sense of some of the capabilities that we're developing in terms of platforms. We're also working on aerial vehicles, but an issue in terms of trying to do mapping and search with aerial vehicles is the payload and the flight time. So one thing that we're experimenting with is taking one of those platforms and using it as sort of a mothership or an aircraft carrier, as you will, if you will, to carry a drone into a situation where you can still use a ground vehicle and then launch the drone from the back of the ground vehicle to do searching of elevated terrain and things like that. When I first started talking to Alan about the opportunities for the faculty summer research program, we started kind of brainstorming applications for the Navy. And one of the first things that Alan brought up was the exercises like this, where there are first responder exercises on the self-defense test ship. And so I think it would be a great opportunity in the future once we're back to live face-to-face meetings to be able to do some exercises where we provide situational awareness for first responders entering the self-defense test ship. So we can provide 3D maps and images to assess damage, and then locations of and possibly other information of possible survivors. Okay, next slide, please. So I want to kind of be a little bit formal. So this is the only equation you're going to see in this talk. And it's a fairly simple one. I just want to formally state kind of what the problem statement was that I addressed over the summer. And that was, if you're faced with a robot that's deciding where to go next within this unknown environment, where should it move next to maximize the area searched by its cameras without encountering an obstacle? So in the picture you see on the left, the sort of greenish gray indicates areas that are unknown to the robot. And then the light gray indicate areas that it's a little uncertain about if there's an obstacle there or a wall there or not. And then the dark or black are areas where there are definitely thinks there's obstacles. And then the magenta kind of cones are the visual footprint of the cameras on the robot. So in this scenario, I have a camera looking forward, backward, and left and right. So there's 4 cameras on the robot. And so if we're trying to decide where to go next, we have to kind of pick to go somewhere that's at least a known non-obstacle area, but we want to pick it in such a way that we maximize the coverage of these magenta cones. So we want to kind of sweep these magenta cones over the known area or the known environment. And traditionally, robotics literature doesn't really consider the camera view of this, but their goal is a little bit different in that they want to just build maps. And so if your goal is to just build maps, you would just always want to go to the edge of your known map and try to extend the map further. And this is known as frontier exploration. And so in either of these cases, whether it's search or frontier exploration, you're still managing this trade-off between gaining new information and how far you have to travel to get that new information. So there's this kind of time value kind of idea of, do you take nearby locations where you might gain less information, but you can gain it more quickly? Or do you go farther away from the robot kind of into a slightly unknown territory to gain possibly more information? And that's what's represented by this formula here, where D is the distance of the candidate location from the robot's current position, and U is the utility or the information that's gained by going to that new location. And then the alpha is the kind of the trade-off variable. So this is sort of the tuning variable that we can use to trade off between distance and utility. And so then at the end of the day, you have this big list of candidate waypoints, and you have to decide among those candidate waypoints, which should I go to? Which one minimizes this cost function or this optimization function? Okay, thanks, Alan. So at a high level system diagram, this is kind of what the system is that we're working with. So we have a 3D LiDAR sensor that provides high resolution data of distance to nearby objects. And we have wheeling odometry and possibly inertial measurement units on the robot itself. And you can combine this data into simultaneous localization and mapping algorithms known as SLAM algorithms to produce an estimate of the pose of the robot and a 3D point cloud map of the environment. So you can figure out a map of your environment and the pose of the robot or the estimate of the location of the robot within that environment. And that's extensively studied in the literature. We utilize an off-the-shelf approach called Lego Loam, and we're currently switching to a new approach called LEO-SAM, but both of these are just acronyms that for papers and algorithms that are published in the literature. So that's not what my focus is here. So my focus is everything to the right of that point cloud. And that is producing something called a 2D transversability map. So this is a map that is like a grid-based map that tells us in the environment what cells or what areas in this environment could our robot traverse. And so we look at things like the slope and things along those lines. Are there drop-offs and things like that, and take that 3D point cloud and convert it into a matrix, if you will. And then at the same time, we have the 2D camera view map. And this is taking that 3D point cloud and sort of the field of view of our camera and estimating what areas within the environment we've actually seen with our cameras. And so then all of these pieces, the traversability grid map, the camera view grid map, and the pose of the robot can then be used to generate the next waypoint or the next candidate location for the robot, given that optimization function that I just showed you on the previous slide. Okay. So this is a picture of what the traversability map looks like. Again, so the dark cells indicate obstructions, and the light cells indicate an open area that we would be free to travel in. And then the green cells, or the kind of light gray cells around the outside, indicate cells that are unmapped. So we don't know what's behind the wall, right? So if we're just using our LiDAR sensors to detect obstacles, you don't know what's on the other side of the wall. So those are kind of considered unknown areas. Okay, next, please. And this is what the camera view map looks like. And the magenta areas indicate all the areas that are searched by the camera given the trajectory of the robot. And so I put this in to kind of illustrate the issues with using the traditional frontier exploration approach when your goal is to actually search the area. And so if the robot were carrying out a traditional frontier exploration, it could build the map or the traversability map of this room just by driving down the center. So you have a kind of a hallway at the bottom of the screen and a hallway at the top of the screen. If the robot just drove right down the center of this hallway and through this room, it could build this map without needing to deviate from its path that drives right down the middle. But given that the cameras have a shorter range than the LiDAR sensors, it would not be able to search on either one of the walls along the sides of this room. And so the traditional approach to frontier exploration sort of leaves those corners of the room unsearched. And so I've highlighted down at the bottom left of the screen an image in the simulation environment that we use of one of the artifacts that we're looking for, which is in this case a red backpack. And it shows up as this single black square in the traversability map. So it's detected even by our LiDAR sensor. But you see it's right on the edge of the camera's range of being able to actually accurately detect something at that range. And so under the frontier exploration approach, you would have just driven right past this artifact and missed it. And so that's why it kind of justifies the need for this new approach that we're developing. Okay, next slide, please. This is a picture of the overall simulation environment that was used. I developed the software using something called ROS, or Robotic Operating System, and Gazebo. And so these are sort of industry standard robotic simulation tools and robotic software tools. The picture on the left is sort of the big environment of this industrial area that we were tasked with searching for the simulation tests. And so that map was generated by just manually driving the robot all around and creating the 3D point cloud map. And then the picture on the left is just an example of what the robot would be looking at. So there's like big, like generators and air compressors and pipes and drop-offs and things along those lines, and tight corridors that the robot needs to search down between. So this is kind of an image capturing what the environment was that we used for the simulation. Okay, next slide, please. So this slide captures the results of the simulation experiments that I ran. And the takeaway message here is that the vision frontier, so if we design the path planning algorithm to take into account the camera search, we actually significantly outperform the traditional frontier exploration, or the map frontiers approach, in all cases on average, and do better than even in the worst case scenario, except for one particular case. And so in this case, we set the value alpha. Remember, that was the trade-off between picking up information nearby the robot and driving farther away and picking up more utility or more information. And so in that case, when alpha is 1, we strictly seek to just go to nearby locations. And when alpha is 0, we try to ignore distance altogether and go to the best information gain location. And so this is kind of a spectrum in between those two. And if you look at the columns on the right for the average, you see that the vision frontiers actually end up searching more cells of the environment than the map frontiers in every case on average. And this was compared to work that was generated from the paper referenced below. Okay, next slide, please. So just to wrap up and talk a little bit about future work. So when the goal is autonomous search and rescue rather than simply autonomous mapping of some unknown environment, the performance can be increased by considering the utility of each candidate waypoint related to the search sensor field of view. So whatever sensor you're using, if you take into account the field of view, then we show that there is benefit to doing that. Where we're currently at, we're currently integrating a new 3D mapping algorithm and a new LiDAR sensor into our hardware that's called LeoSam. I kind of alluded to that earlier. And we're also investigating using reinforcement learning and simulation to train our algorithm so that with more time, we would improve the amount of area that could be searched. I will say that this is proven difficult. It was one of my goals in the summer. And part of the difficulty is that each one of the trials in the simulation experiment that I mentioned takes about 2.5 hours. And so when you're trying to train these algorithms using simulation, you really need to parallelize the operation so that you're running the simulation on many, many computers. And so that was a bit of a bottleneck for us in terms of being able to successfully train a reinforcement learning algorithm. And then in the future, I'd really love to see us be able to test our approach on the self-defense test ship, or possibly at FathomWorks in one of the areas there, like a warehouse area or something along those lines. So again, thank you for your attention. And I take any questions you have now, or Alan, are we going to take questions at the end?
Yeah, so we'd encourage folks to use the chat feature if they have any questions, but we have just a minute or so. If anyone has any questions they want to address with Dr. Isaacs, we can do that. Otherwise, we will move on to Dr. Solteys. Okay, I don't know. Do we have anything in the comments or?
Oh, just a nice overview.
Nice overview. Awesome. Okay. All right, I am going to pull up Dr. Solteys' presentation. Like Dr. Isaacs, Dr. Solteys joined us this summer. He's worked with the Navy and our command for a number of years, helping to establish the original educational partnership agreement, and then joined us this summer under the ONR Fellowship Program. So I will turn it over to Dr. Solteys, and I will pull up your presentation here, Michael.
Thank you, Alan. Can you hear me?
I can hear you. Okay, over to you, sir.
Thank you. As Alan said, I am Michael Solteys. I'm a professor in computer science at CSU Channel Islands. Jason, whose great presentation on robotics you just heard, and I are colleagues. We work in the same department, and we were both lucky this summer to participate in the ONR Fellowship hosted at Port Hueneme under the supervision of Alan Yeager. Alan, next slide, please. So I wanted to say a few words about the fellowship itself before I jump into the presentation. For me, the fellowship was Port Hueneme, NAVC under Alan Yeager and Vance Brahowski. With both of them, we have a long-standing relationship. They're a part of our advisory board in the Department of Computer Science. Our students end up, many of our students end up working at Port Hueneme. Port Hueneme personnel take classes at CI and teach them as well. So we have a we have a nice relationship going, and ONR is a very good part of that. And this last summer, I was lucky in that I worked with many different people at Port Hueneme. I worked a lot with Corlin Akers, and also with Eric Johnson, with Brandon Dooley and Sarah Dooley, with Socrates Frangis, with Matthew Ward, with Jason Bickford, and many others. And I think they would agree that this summer's ONR was really successful. And so why did it work? So I think one of the reasons it worked is that the Port Hueneme folks were very generous with the time they spent with me, explaining to me their research problems and the goals, and also the context and the realm of what is possible. And I think collecting all of that and doing some background reading really helped me to target what I was doing in a way that the Navy would find useful. And at the same time, these were problems of great interest to me. I ended up working on 4 different problems, and I'll talk about them in a moment, in different areas. And that just emphasizes the fact that there is a lot of potential in the collaboration between Navy and academia. In the end, following the initial discussions and the meetings and understanding the context, we were able to identify some very well-defined projects where we could make some push in 10 weeks. And as Alan also mentioned, there is a long-term educational agreement between CSU-CI, our university, Cal State Channel Islands, and Port Hueneme. And that educational institution is good because it fosters exchange of ideas, training of PhD personnel. So for example, last summer, we were able to offer a Python programming course for PhD folks, and our faculty like Jason and myself and others from the mathematics department are able to participate in the research agenda at Port Hueneme. So in essence, ONR was great, but one of the good things about it is that it leads us into a long-term future collaboration. Alan, next slide, please. So the projects I worked on this last summer were the following 4, and I'm going to describe them very briefly. I only have about exactly 7 slides. So I am going to spend time on each of them, giving you a flavor and an idea of what the project is all about rather than technical details. So the 4 projects I worked on this last summer were cloud migration, and that was under the umbrella of the large project undertaken by the Navy in digital transformation. The second project I worked on was correctness of machine learning, and this was really neat. And I'll talk about that a little bit later. And it went back to work I did as a PhD student, thinking that work was so theoretical and that no one would ever apply it. Well, in this case, it found a great application, and in general, it's finding a great application. And I'll mention that in a little bit. The third project was data workflow structure that we built. That is, we built a prototype of a data lake that would be able to absorb a lot of data quickly, either in batch or data absorbed in a streaming-like fashion, and then how to give different stakeholders the ability to analyze that data in different ways, from complex SQL queries to machine learning to tools to visualize the data and make decisions quickly, such as Kibana. And then the 4th project is a project that is still ongoing. In fact, all 4 projects are ongoing, but the 4th one especially, with Socrates Frangis and Jorge Lacoste, we decided to write a paper on how to help the Navy with its cybersecurity workforce development. How do we help the Navy find the people to do cybersecurity? And once they are hired by the Navy, how do we give them a structure where they can learn and become more proficient and advance in the field of cybersecurity and serve the Navy? So I have slides for a couple of the projects that I mentioned here. Let me start with the cloud migration. So everybody's moving into the cloud, and Forbes magazine and the Gartner report are saying that, well, this is the new way of doing IT. Companies and businesses are moving. The cloud itself is $100 billion a year business, and Amazon Web Services, which is the world's largest cloud provider, published its last quarter's earnings at $10 billion. And the reason for that is that it makes sense from a business perspective to move into the cloud, because you save 80–90% of your expenditures versus running the same infrastructure in-house on premises. So it makes sense from a business and financial point of view. But the biggest concern everybody has, and of course it's the biggest concern the Navy has, is my data going to be secure in the cloud? How do I make sure no one else but me has access to it? So there is the aspect of security, and that ties in nicely with the 4th project of cybersecurity workforce development. And also, it's a certain change in paradigm. IT departments have to get used to this new way of doing things, and you have to develop a workforce that is capable of, first of all, pushing your content into the cloud, and second of all, operating on it. I think this is unavoidable, and there are some solutions that would assuage some of the concerns that the Navy may have, such as the Gov Cloud run by AWS and Microsoft Azure JEDI contract with the Department of Defense. where there are heavy assurances of the safety of the data. But in the long term, the Navy will need to move into the cloud to some extent, because the tools in the cloud are impossible to replicate on premises. Tools such as clusters for machine learning and artificial intelligence applications and forecasting, and all those things that require massive data centers. Perhaps you could build one yourself and then maintain it and keep up with the development in the industry, but it would be extremely expensive and it probably wouldn't be as good. So we wrote a report about the different components in a cloud migration, and so that was the first project. The second project, correctness of machine learning algorithms. So let me talk about that a little bit. Alan, if you can go to the next slide. So what is correctness of machine learning? Well, kind of everybody nowadays is using machine learning. There is a large company here in Ventura County, and I spoke with their CEO a few months ago, and he told me that the company will make just enough money if they run their operations as normal. But if they want to make money, if they want to make a profit, they have to deploy artificial intelligence / machine learning to optimize how they procure their inventory. They build things. They build medical machines, and the type of optimization that they require to make sure that they have all the parts and all the components and all the materials at a given time when the orders are necessary. To optimize that, this cannot be done by hand. It's too big, it's too complex, and they optimize it based on their history and the predictions of the future. In order to combine all of that, they need a data lake where they throw all that data in, and they need machine learning, artificial neural network algorithms in order to be able to study that data and draw conclusions. Okay, so machine learning is now used by everybody. It's used to detect anomalies. It's used to, as in the case I just described, for inventory. It's used in optical character recognition. It's used in the problem of vision and recognizing objects and classifying them. But it's a bit of a, the name itself, it's a bit of a black magic, machine learning. Well, machines don't learn. What machines do is they run algorithms, and these algorithms use perceptrons, and these algorithms use neural networks, and they assign weights to paths, and it's a complex procedure that is difficult to track. These are algorithms that are not case-based, if-then. They're algorithms that kind of take off on their own, and based on the history of the data, they come up with a good approximation to what the future might be like. It's connected to work done in the 1990s and online algorithms in many ways. But the issue is that there is always that 2% possibility of a mistake, of not being accurate, of making a bad decision. Well, that may be unacceptable for the Navy. If you're deploying machine learning into a weapons system, a 2% failure or false positive or false negative is simply unacceptable. So what the Navy is interested in, and Sarah Dooley suggested this problem to me, and I found it really interesting, is come up with a scheme that can prove the correctness of the machine learning procedures we have in place. That eliminate that 2% error. Have an explicit analytical proof of correctness of this approach to this problem. So I thought about it quite a bit. I ended up writing a paper about it. We're discussing it and thinking where to take it to from this point. Next slide. So I'm just going to finish a sentence related to the previous slide. So the question here was, how do you prove the correctness of a machine learning procedure, and therefore assure all the stakeholders who are relying on that algorithm that things are going to go well? And to do that, I had to go back to work I did in NP completeness about 20 years ago, and proofs of correctness of algorithms, and put it all together and come up with a system and an approach. And we haven't solved the problem 100% simply because it is not possible. It's an NP hard problem to prove the correctness of machine learning algorithms. And maybe some of you know that NP hardness is the way computer scientists characterize things that are not solvable using today's technology. So maybe with quantum computing, you would be able to do it, but not with the algorithms and the approach we have currently. The third project that I eagerly jumped on was this idea of a data workflow project where we designed a prototype of a data lake. And I was able to get from the Navy some data with which I could test it. The Navy is interested in this project because they want to be able to predict anomalies in complex systems. So you want to know, you have a ship with all its components, something is going to break. Based on the current behavior, based on the history, you want to be able to predict what is going to break when, what is going to break next. So the approach, and this can be, this approach can be used with many different problems, is to build a data lake on which you could run analytics. And here what you have is the design of the data lake. In fact, I based it on a data lake that AWS designed for scientists studying COVID, both the spread and the biology of the virus itself, the epidemiology and the biology of the virus. AWS created a very sophisticated data lake for scientists all over the world to be able to test their hypotheses and to add as code solutions to the problems they are working on. So I used that but modified it a little bit to that need that I explained before. And here you have an example of you have a diagram of how the data lake is constructed using a very neat visual tool in AWS that allows you to construct a complex infrastructure IT solution visually, putting the components together. And then on the left, you have a diagram of a complex query using a tool called Athena that is able to draw complex conclusions based on the data lake. It goes in there and you can ask it, well, how many free ICU beds are there in Ventura? And how many people are getting sick, and what is their demographic? And based on that, then can you do this? And then can you add that? And you can construct these complex queries and query the data lake. Next slide, Alan, please. And then we connected it with work here. We did a little bit of work with Ventura Health, where we built a simulator in Python that then our health department at CI, Cal State Channel Islands, was using a little bit. And I was comparing my own simulations in a simulator I wrote in Python. And if you want to take a look at the simulator, you can go to the link that is specified there as the first point and compare the simulations I would get against the data in the data lake that was constructed, and have a kind of a sanity check to see whether either one of those solutions matches closely what is happening on the ground. Next slide, Alan. I believe the fourth project that I mentioned, yes, was the cybersecurity curriculum. So in my university, we are part of the Governors of California task force for developing a cybersecurity workforce, and we're working in the educational track. And Port Hueneme is very interested in that because they can hire a lot of folks who specialize in cybersecurity. We have a minor in cybersecurity that many of our computer science students take, and our students get jobs right away, but we want them to stay in Ventura, and we want them to work for the Navy as well, and be here, stay in the county. And the Navy is very interested in hiring people who live in the county because those people are here to stay. They have families and they have an infrastructure. They have relatives, and they're a long-term commitment to Ventura County. So to give you an example, last year of our 15 students who graduated with a minor in cybersecurity, 7 of them were hired by the Navy. In different capacities, but all of them related to work in cybersecurity. I think maybe 1 or 2 of these positions were internships. They weren't permanent positions, but they become permanent positions if the students are interested. In any case, this final project, this cybersecurity project, we're working on a white paper with Socrates that will match what we do in academia with the needs of the Navy and the context of the state, where there are 35,000 unfilled positions in cybersecurity, many more nationwide, about 10 times as many, and come up with a way that our students who work in cybersecurity will find a meaningful career path working for the Navy. And that is the summary. Thank you very much for listening to me. Thank you.
Awesome. Thank you very much, Dr. Solteys, and appreciate your long-term relationship and commitment to our command and working with NAVFAC XWIC also. And so really appreciate that, and continue working with you, hopefully even into the rest of this year and next year. We're going to change up just a slight bit on the schedule here. I'm having a little bit of trouble getting Dr. Donavon's presentation. So hopefully you can email that to me. While you do that, if it's okay, I'm going to switch to our friends down at San Diego State University. I see Dr. Shin online, Dr. Larson. I'm not sure who's going to give the presentation. We can unmute. It's like Dr. Shin, if you are. Just a kind of
yeah, actually, one of my students, Alex Nessler, is going to make a presentation.
Okay.
So I'll just briefly introduce ourselves and then turn it over to Alex.
Perfect. Sounds good. And I will just jump in for just a second while Haley's unmuting Alex. We've worked with Dr. Shin, Dr. Larson, Dr. Elkins for a number of years on the NEEC program. We've hired some of their best students are with us now, and so it's been a great relationship. And I think this is maybe the 3rd or 4th year you've worked with us, and I know you work with Corona and a couple other warfare centers too. So just another long-standing strategic relationship that we've enjoyed with the university down there. So with that, Alex, it looks like you are online. I will share the screen, your presentation here, and let you have at it.
Okay. Before Alex starts, let me briefly introduce our team. Thank you, Alan. Good morning, all. Personally, I am very honored to work with the Navy on a very practical project. We are a team of 3 faculties and 3 students from Information Systems and Homeland Security. And we conducted a cyber threat intelligence project, another cybersecurity project. As Alan introduced, this project was funded by the NEEC program that puts much emphasis on student engagement and student learning. So during the project period, faculty role was limited to providing the initial research idea, providing guidance in research methodology, research directions, and necessary feedback so that the student team could achieve the final goal of delivering the target system. With that said, I will turn it over to Alex Nessler, who has been leading the student team and successfully delivered the project. Alex?
Thank you, Professor Shin. So hello, my name is Alex Nessler. I was the student team lead for this project over the course of it. And one of the things I want to point out too is that, traditional cybersecurity, you might think of, College of Engineering, College of Sciences and Math, and Computer Science. We, however, are in the College of Business and Information Systems, and we specifically deal with data problems or even big data problems. And that's why this one with the cyber threat intelligence was well suited to things we were already used to working with, even though we weren't as technically inclined as you might see some cybersecurity and from the College of Sciences with a CS degree. However, I think that during our research and the prototype we developed did, I think, solve the problem that we were asked to. So Alan, if you can go ahead and move to the next slide for me. So one of the things that happened since 2016, organizations within the same industries had overcome information sharing barriers, and they began sharing more information about the tools that were being used to exploit their systems. Due to this, there was an increase and a rise in the cyber threat intelligence reports being generated. And today, there exists many open source and fee-based service providers that provide these reports. However, the number of providers that provide cyber threat intelligence reports and the sheer number of reports each provider provides causes information overload. There's a lot to go through, a lot to sort through, a lot of duplicate information, and it's just too much for any analyst to be able to analyze and manually process in a reasonable amount of time. So one of the Navy's problems is that there's no current system, or that it prompted this research, was that there's no current system to just quickly correlate threats to network assets such as warships. Alan, can you go to the next slide? So as I was already hinting to, cyber risk management itself is actually a component of risk management overall for an organization, but it's an important one that's rather unique. And in order for an analyst to properly perform cyber risk management, their situational awareness demands the triangulation of assets, threats, and vulnerabilities. Assets include things like the data and information that's in transit or at rest on organization lines and devices, and as well as the software and hardware components that make up the devices and systems an organization uses to accomplish their mission objectives. Threats include things like the threat actors and the threat groups that are attempting to access an organization's assets, as well as the malware tools that are used by the threat groups, and the phishing and social engineering techniques that are deployed by these threat actors in order to exploit the human factor and inject their tools into an organization's network. Vulnerabilities are design flaws and logical flaws that create weaknesses which are then exploited by these threat actors in order to gain access to the organization's assets. Analysts need to be continuously alerted to these vulnerabilities that are currently being exploited by threats to gain access into an organization's assets. Next slide, please. All right, so our research for the threat intelligence modeling environment was centered on this concept of a dynamic and automated correlation of continuously updated threat, asset, and vulnerability data. There were two key standards that we used from the National Institute of Standards and Technologies that enabled us to be able to triangulate these threats, assets, and vulnerabilities. The standards were the Common Platform Enumeration, which uniquely identifies a specific version of operating systems, software applications, or hardware assets, as well as the Common Vulnerability and Exposure Standard, which uniquely identifies vulnerabilities that exist in those specific versions of operating systems, software applications, or the hardware assets themselves. What our framework would do under the hood is it would collect the organization asset information. Now, time can actually be integrated to accept asset information in several ways, whether it's through network audit scans, local audits on each device themselves, or perhaps there's existing asset or IT service management databases that contain such information. The framework we developed is able to take this information from those sources and parses it to create common platform enumeration candidates, which are also subsequently validated to ensure accuracy. Once the framework gets the common platform enumerations for these assets, it is able to associate these assets with the vulnerabilities the assets contain, the weaknesses the vulnerabilities enable, the common attack patterns used to exploit those weaknesses, and where applicable, an association to the MITRE adversary technique, tactics, and common knowledge framework. With the local common vulnerabilities and exposures known, the framework can automate the association between common vulnerabilities and exposures that come from cyber threat intelligence reports with the common vulnerabilities and exposures that exist in the local environment. Next slide, please. So the time prototype that we developed was centered around being able to provide automated alerts that can be tailored for an organization's context, that are designed to improve an analyst's situational awareness and help to assist in quickly identifying and prioritizing the most vulnerable assets for fixes. The prototype we developed to test this concept was able to take as inputs the asset information from any one of those sources I mentioned before, the NIST vulnerability data. Something that's actually not listed there was also the MITRE common weakness enumeration, MITRE common attack patterns, and the MITRE attack framework, as well as X-Force vulnerability data and AT&T's Alien Vault threat data. We took this information and our system was, the prototype was able to output asset vulnerability threat correlations and supplemental information related to those correlations. Next slide, please. We were going to have a demonstration. We tried to send Alan in time the correct slide set that had this on it. Unfortunately, we weren't able to get that in time. But essentially, I was going to review some of the dashboard views that we had created in order to kind of give you an example of the outputs our system was able to generate in an automated fashion. Again, unfortunately, that's not set up here, so I will not be able to show it at this time, and I do apologize for that. So I guess I'll open it up now for questions and answers.
Okay, well, thank you very much. It looks like there's some good discussions going on the chat. I appreciate that. Please reach out to Alex or the team if you have any thoughts, ideas, or questions. If you have something now, you can kind of click the raise hand. We can unmute you. Otherwise, we will move on. I'm going to I'd like to introduce Dr. Plamen Donavon next. He is with the University of Missouri out at Kansas City, and we've started to establish some good relationships with him and his team out there. They do a lot of interesting work. He does a lot of interesting work also. And so he was able to join us this summer, again, virtually, to look at some of the issues associated with UAVs and countering UAVs. Most of you have probably seen in the news some of the open source reports as far as the threats that small, even commercial UAVs can pose to Navy ships. And so with that, my friend, I'm going to turn it over to you. I have your slides. I will pull them up, and if you can unmute him, and hopefully we can hear you. Let's see here. Plamen, Donavon. Sorry, we'll get you here in just a second.
Hello.
Excellent. All right. We can hear you. Let me pull up your slides.
Hello to everybody while Alan is putting the slides on. A little bit about background about this research effort. First of all, Alan, thank you very much for the opportunity to participate in the Hueneme research program for faculty this summer, and also to present a summary of what was accomplished so far. Jason and Michael set up the stage to discuss interesting aspects of the technologies that we are all collectively working on, and especially the aspects for machine learning and artificial intelligence, and I'll share with you later on in the presentation my view of perhaps better names for these areas of research. Briefly, I will discuss an effort to utilize artificial intelligence. Everybody's using this nowadays, and to complement available data with reconnaissance for automatic dependent surveillance broadcast, which, as of some of you may know, January 1st of this year, FAA required all aircraft, with minor exceptions, to transmit this. Immediately I will say that one disadvantage what we're trying to do, and in general it is protection of critical infrastructure. It is that this broadcasting, it is automatic, it is dependent, it can be used for surveillance. However, it is voluntary, it is cooperative, and also there is an aspect in which it could be spoofed. Otherwise, the identity not theft, but misrepresentation of who the aircraft is. And all these things will be reflected later on. Slide, please. So before going to the introduction of concept, briefly, I have spent more than 20 years in chem and bio, defense, and other projects in Siberni. About 3.5 years got involved with a major undertake sponsored by the Office of Naval Research, Counter-UAS, and our focus was on new sources for high power microwave generation in order to enhance the kill chain from detect, track, identify, and obviously neutralize. So the utilization of ADS-B was conceived as an enhancement of the first three aspects of this neutralization chain, and more specifically, it is what else we can use to complement and enhance the detection, tracking, and identification of bad actors or bad intention. So we conceive, and in one STTR during the spring semester, we explored the open source air traffic data to improve the ability to detect bad actors. The way we did this, we wanted to do it really inexpensively, very flexible, agile, easy to deploy, operate, and with a lot of flexibility to the end user, capability to integrate with additional available systems, including radar and different means of monitoring of the air traffic and objects, authorized and unauthorized. Basically have good real-time situational awareness around area that we are interested to monitor and protect. So our our approach was to use very inexpensive software developed radio. You can see one used is a USB type device, and from anywhere from $35 to about $1,000, $2,000 units. Obviously, they have different capabilities. Nevertheless, they can be used to develop ad hoc neural net, ad hoc network around, let's say, Port Hueneme, and complement this with software to monitor in real time the data transmitted from the ADS-B on board of the airplanes, and use this to identify, classify, discriminate the air traffic. In addition, if we process historical data, we can detect and report, or at least be aware of potential threats based on abnormality detection. And what I mean by this will be obvious in a few, we'll be viewing the several of the following slide. With this, one can detect trafficking, smuggling, asymmetric attacks, defining of new corridors. And again, this can be used not only on land, but at sea. Slide, please. We were using, for the development of the system, the Open Sky network. And perhaps some of you are familiar, a vast amount of data. So obviously big data tools have to be employed. And also in the STTR with a local small business in Lawrence, Kansas, Calscott. They have a working relationship with Aerion. It's a subsidiary of Iridium, and from them we do have air traffic data provided by satellites. As you can see, pictured on the slide on the right. Slide, please. So the technological approach was to develop the low-cost network, deploy it at the area of interest, and again, currently Open Sky in Europe at least is based on a voluntary participation. The data is posted and updated daily on their website, and I have used this data in order to develop the artificial intelligence and machine learning abnormality detection algorithms. So in order to do this, we obviously did the historical review of available research already completed in this area. We tried to replicate some of data, get in touch with some of the active research participants, and try to replicate and enhance some of their results. Slide, please. So before one can do any good work with the developed algorithm, we have to be sure that the data that is coming into the developed engine has to be with a sufficient level of quality. And what I mean by this is pre-processing and integrity check of the available stream data real time. And for historical records and forensic analysis, this is easier because could be done offline and with a little bit larger windows of available for processing. For real-time streaming, we develop a pre-processing algorithms which exactly sort out any duplication of records. They identify missing data, and the end result is to provide what is called a feature vector for each aircraft of interest, and put this feature vector into a scalable structural database. So the traffic pattern mapping could be done real time based on this feature vector, and one can follow the end user using graphic utility interface, can view in real time or forensic analysis historical data, mapping evolution and abnormality detection of non-reasonable, non-collaborated, any deviation that does not have any reason, for example, weather or some other reason for corridor air traffic and corridor changing. Slide, please. Here you see a typical file, data records ADSB on A from the Open Sky, and each one of those records which is transmitted once a second, has 17 fields, which are presented under B. And also you can see on C a real-time capture of a single flight here around Kansas City. Don't know which date was, but obviously the time is like 18 o'clock. So using Google Map, again, very easy to monitor and follow real-time air traffic. Slide, please. On the left A, you see the developed graphic utility interface. One of my favorite tools is LabVIEW of National Instruments for easy integration. And actually, National Instruments being very active in the field, I really like their universal software radio peripherals. So this combined with other software-defined radio tools and the GNU radio, one can develop very rapidly quite sophisticated and a very good application software to be utilized, and at least proof of concept of the research. So on the right side, you can see that a specific air carrier of interest could be tagged with any label and can be followed real time, as you can see on the next slide, please. Here on B, you can see that the progress of a flight in real time, and on the C, the map displays area of interest. I think this was around center around the Reagan National Airport, and on the right side of the C subplot, you see all the traffic in color based on the altitude of the airplanes in real time. On D, you can see the subset of airplanes which are above 15,000 meters. Slide, please. And again, all this, the vision is a big situational room awareness screens in which the user can, with that screen, really navigate menus and pick aircrafts of interest. On the left is a different view for some of the high altitude aircrafts. And on B, you can see the view of all aircrafts in this area that are currently on the ground. And when the zoomed in view, you can see exactly where the aircrafts are at the Dallas airport. Next slide, please. So to be more efficient, as the previous researcher identified, you don't need to start from scratch. There are many available tools, and use of these tools in the most appropriate manner, being aware of their existence, because there are so many wonderful people doing wonderful things, can allow you to more effectively, quickly develop application-specific solutions. On the subslide A, you see the framework for aircraft classification. And after that, I don't know if you're familiar with, there is a German, developed in Germany, Hueneme. It's a big data platform with many icon-based sort of pick and place, connect, which allow you very rapidly to develop different algorithms. On B subslide, I have presented how quickly you can put a random forest classifier. And after that, on C, It's a high-level block diagram for classification algorithm and pre-processing of the data. Next slide, please. Okay, thank you. I promise you to give you my my view on better names for machine learning. Actually, to all my students, very often I tell them it's more of a machine teaching, because we do the machines how to perform what we would like them to do well. And more and more, I am a voice for using the term instead of artificial intelligence, synthetic intelligence. So I'll be very curious to know your opinion if this is, what's your opinion on this text, synthetic intelligence? Because after all, we synthesize this intelligence-like capability of our modern computing system. So with this, I would like to thank Alan again for the opportunity for the summer research program. And now, thank you very much for attending. Perhaps I was able to introduce you to some interesting aspects of what is possible. Thank you.
Outstanding. Well, thank you very much. Appreciate it. Another really interesting potential applications for the Navy. And so like all of these, right, there's research that's being done at the universities, and our interest and engagement is really being able to look at possible applications of that research and understanding where the research is going and how do we engage and possibly plug in. So great, thank you very much. Our last one here is Ryan Nguyen. Ryan joins us out at State University of New York in Buffalo. We have worked with that university and Ryan and some of his colleagues and professors out there for the last year on a NEEC grant, looking at how do we, generally we're looking at how do we do predictive maintenance, how do we do remote maintenance, and so there's a lot of aspects associated with that. And so Ryan and his team kind of tackled that under the NEEC program last year, and then Ryan joined us over the summer virtually as an intern to keep working on that. And so wanted to give him a chance to explain what he's doing, some pretty interesting stuff, also very relevant to the Navy. So Ryan, looks like you're online. I will pull up your presentation here and share it and turn it over to you.
Awesome. Thank you, Alan.
Okay, over to you, Ryan. Thanks very much.
All right. Okay, yeah. So basically what I've been working on is this this pipeline or this algorithm that'll leverage handheld augmented reality and infuse deep learning in a way to kind of improve the training process and make better predictions of problems moving forward. Next slide. So, handheld devices are very valuable because they're portable, accessible, easy to use. We all have one. It's also going to be, where a lot of technology moves towards as we want to become more and more connected to technology. It's going to have to be on us at all times, or as much as possible, in order for us to kind of embed ourselves further into that world. Next slide. Augmented reality. This is the idea of overlaying some virtual object over on top of like a real world object. It's helped people get a better spatial understanding of the system. It's increased work efficiency. It's allowed people to solve problems that they wouldn't normally be able to solve because of the better understanding of the system as a whole. So it's been a really useful tool, and we want to try to see if we can leverage this informational tool to maybe help deep learning in a way. Next slide. So deep learning, I think a lot of people here have kind of talked about AI and machine learning. So this is going to be just really quick here. It's a universal approximator. It learns how to map from one input to one output, or multiple inputs to multiple outputs. And they're really rising in the past like 5-10 years or so because of the ability to compute at the way that we can. So these are extremely powerful tools. However, we are battling the battle of accuracy and efficiency and, the large data set problems. So we're trying to see how we can manipulate these with augmented reality to try to improve what the current issues are with deep learning. So move on to the next slide. So here I'm going to pause for a second to kind of give you an understanding of why, I'm calling this or introducing human AI synergy. So with the things I was previously presenting there, which was, augmented reality, handheld devices, and deep learning. How do they come together? How do we leverage the benefits of all of those things to try to come up with a system that is extremely valuable and effective for training these networks or making better solutions to problems? So a handheld device in augmented reality are usually used by a human, right? So you usually have a human interacting with the augmented reality environment, manipulating the objects in the scene. And this can be displayed on a handheld device, a projector device, anything. But on a handheld device, you can create these virtual objects pretty much anywhere you go. I mean, it's very mobile. It's in a closed, compact system, so you can use it pretty much anywhere. So it's extremely valuable. But that's all human used, right? Now, an AI, right, is a deep learning system. A deep learning system processes data, takes one input and then gets an output out of that. However, all it's doing is processing information, processing data. So we have the ability to access a tool to help us better understand information or data, right? And then we can also have a system that processes that data to make predictions. So if we can fuse those two concepts of us being able to get a better understanding of the data and feed that better understanding of the data into a deep learning algorithm, we can improve the way that deep learning algorithm learns. So here's this quote about human AI synergy is just fusing the way that humans and AIs work together and communicate to maximize the creative behavior of humans and computers and collaborate to leverage the strengths of both. So this is kind of the strings that I'm playing right now, the ideas that I'm trying to get at. So keep this in the back of your mind when I start developing this pipeline. So next slide. So one of the current challenges that I wanted to tackle is minimizing the training data set size. So a lot of deep learning algorithms are very data hungry, meaning that they require a lot of information in order for them to properly train and make predictions about what's going to go wrong with the system or classifying between some animal or some other animal or some car and an airplane. You need a lot of data for that. So how do we solve that problem? Next slide. So current solutions are using few-shot learning through multimodal inputs and meta learning, reducing noise in the data that's collected so that you have a more accurate representation of what each class is or what problem might arise, just more information that is cleaner and there's not as much disruption. Another solution is using a digital twin. Okay, so I'm going to go through these next slides, kind of developing each of these things in a way where it kind of explains how we can use all of these tools to improve the deep learning pipeline. So next slide. All right, so digital twins. Digital twins, as this is showing right here, is kind of a representation of a real world object in a virtual world that you can run simulations on. So the idea is that you can take a system and information about that system. You can represent that system in a virtual world, and then you can apply different conditions to that, saying like some different loading conditions, different environmental conditions, and that can get you a prediction of what might happen down the line. So move on to the next slide here. That being said, I have this pipeline that I've kind of developed that is going to be easily explained through an example, but I wanted to introduce kind of the main components of this in previous slides so you kind of understand how it all comes together. I want you just to focus on 4 different components here, and I want you to look at the first part of this, which is the top, where you see the digital twin and you're running simulations on that. The second part I want you to focus on is the bottom half of this, where you have this augmented reality environment and the traversing of a space using a reinforcement learning algorithm, that part, that's going to be a fraction of this pipeline that's important to focus on. This filter, which is the idea of, finding the difference between the systems. And then lastly, the final prediction block. So the final prediction is that last deep learning block to make a prediction of the diagnostics of a failed system. So this whole pipeline is really big, really messy. It's got a lot of components to it, but we'll break it down in the next coming slides. All right, next slide. All right, so I'm going to go and step through a fan example to kind of explain how this comes together. Next slide. So some example outputs that you can draw from this is maybe that there'd be like a broken blade on the fan, a broken cage, or all of these other modes that I'm describing here. These are things that with the entire pipeline in place, we'd be able to try to mimic these situations and create a data set off of this, but we'd want to be able to identify any of these problems. We'd want to be able to find what's wrong with the system and how do we fix that, right? So these are examples of what could go wrong. There's definitely more. It's just, this is a good way for you guys to understand that, this is what we're looking for. So next slide. For the first part of that pipeline, in order to develop a digital twin, you're going to need system information. So you need sensors on that system. Here's just an example of a few sensors that you could use to gather that information to develop a digital twin. Next slide. This kind of goes into the idea of developing the digital twin. So the digital twin is going to be a physics model based representation of the system, right? So this is going to take in real world information, create a system, create a representation of the system that we can run simulations on. So the next slide is just running simulations and getting the digital twin. So this is actually getting the digital twin, developing a CAD model that you're able to run simulations on for future prediction. Next slide. Running simulations, adding different loadings for different times to understand what's going to happen. The example that I'm kind of stepping through right now, which is the fan, is just a simplified version of what could this potentially be done. I mean, the simulations that I'm running, just adding loading, like a cyclic loading, can be extrapolated to any type of environmental conditions, like I mentioned before. And you would collect the valuable information, and this will be a representation of the real world system. Next slide. Okay, so now this is kind of where a lot of the chunk of my work over the summer was developing. This is developing this augmented reality environment. Okay, the augmented reality environment is, if you've ever worked with reinforcement learning algorithms, they work into a virtual environment where they can manipulate the actions available and make better predictions or learn how to play that game, or learn how to use the actions available to optimize the approach to whatever situation is in. Here, we're going to use a DQN, which is a type of reinforcement learning algorithm, given different types of actions like walking around a fan or removing different components, to collect data about the system. So right now I'm going to just have the network balance the actions that are available, moving around the object, taking things apart, and then collecting microphone and camera data, so visual auditory data, of the way that it looks and the way that it sounds like under those specific actions. So if you walk around, what does it look like from the side? What does it look like from the front? What does it look like from above? With that information, or what does it sound like there too? So with that information, it's going to try to make a prediction as to what's wrong with the system, but it's going to learn the best way of moving around that object so that it can learn moving around that object to collect the best data for making the prediction. So this goes into like the two different situations, which is the training and the testing. In the training environment, the reason why we develop a virtual model of this system is so that we can use the virtual model in the testing environment, meaning that it's going to try to move around the object in a virtual setting to try to learn the best way to move around the object, and then in the testing environment, convey those actions to the user so that the user can take those actions and feed the correct data to the reinforcement learning algorithm to make the prediction about what's wrong with this fan or what's wrong with this system. So next slide. The most recent work that I have, which is part of this pipeline is developing a paper for this particular part of the pipeline. And I want to get into a little bit of the details of that, because I think that that's important for the understanding of how this actually works. But you have two different networks. Okay, so you have a reinforcement learning algorithm that's learning how to move around a system, which is then feeding that data to a deep learning algorithm to make a prediction about that system. You don't want to have a network that you need to train every time that you have an iteration of a reinforcement learning algorithm, because then that's going to take a ton of time. So I'm trying to leverage few shot learning and meta learning. Okay, so meta learning is this idea that you pre-train a network to identify the difference between certain classes, and then you take the weights of the network and the structure of the network, and you move that to another problem. So you're trying to make different classifications or classify between different objects. Now with few shot learning, it leverages meta learning, which is what I was just describing, to do that with less examples. So we want to use a smaller data set with a pre-trained network to make predictions of things that it did not see in the previous learning step. So when you were training it, you trained it to identify between certain classes, but when you're trying to make the final prediction, or you're trying to train it on like a smaller, on your unlimited data, few shot learning takes those weights in that body of that network, applies the network to the smaller data set, and can make accurate predictions. One example of this is prototypical networks. Basically what they do is they create this embedding space where they have a representation of each class as a point in space, and then the network makes a prediction of like prototype space points that they just kind of find the closest distance to that class, and that closest distance to whatever class whatever class is the closest to that prototype point ends up being the class that it assigns it to. So it's really effective, and it's shown really great results. So we wanted to try to leverage what the results were there to see how much data you would actually need in order for it to result in accurate results. Also, just a quick point, there's multimodal inputs we use because we're using images and audio. A lot of networks out there that are used for predictions are diagnostics and predictions are using multimodal inputs, but not in a few shot learning situation. So we're trying to apply multimodal inputs to improve the few shot learning capabilities of prototypical networks as well. Moving to the next slide. So this develops a current state. This is the output of the reinforcement learning block. It estimates the vibration modes of the system using a late fusion technique. So it takes each modality, feeds it into their own separate networks. Then at the end of each of those networks, it fuses the data into a singular vector, and then feeds that vector into a few linear blocks, and then that outputs a result, basically an estimation of whatever the vibration modes of the system. Next slide. So then this vibration mode from this part of the system gets compared to the vibration modes of the digital twin that was generated in the first half of this pipeline. Those two vibration modes develop this difference, and we use this difference to develop a filter. So move to the next slide. This is the filter. We basically find the difference between the vibration modes, and this filter is applied to the final block of the network. So move on to the next slide. Is applied to this final deep learning block to make the final prediction. So the idea is we're leveraging a lot of different things here. We're leveraging meta learning, few shot learning, augmented reality, and physics-based modeling to try to make the best prediction of a diagnostics or prognostics of the system, just to figure out what's wrong with it and how long it's going to take for it to fail. It's going to take in basically all the information from the previous steps and this filter in order to make the most accurate prediction of what's going to be going wrong. So this is just trying to take into account all of the different fields right now in deep learning and apply them and improve the capabilities of this system. Last slide. So this is, answers to the development question and how we want to move forward. I mean, we want to know, how is this useful for this pipeline? It's going to act as a communication tool between the human and the deep learning, right? So the handheld augmented reality is the part of the system that acts as a communication tool between humans and a deep learning algorithm so that it can make an accurate prediction with optimized data sets. How is this practical? So this is basically, how can this be done? I kind of talked that through, but you are going to train it in a totally virtual environment, deploy that into this augmented reality environment where the user is actually going around and doing the actions that the network is prescribing. And then once it follows those actions, it'll collect the data, and the data will then be processed. How is this useful? It's going to try to minimize the data set size that's required in order for you to make these predictions. And there's going to be less noise in the training data because it's going to optimize the type of data that you get. So it's going to be smaller data, it's going to be optimal data, and it's going to be leveraging the tools that are available to us. So that's kind of what I've been working on. I know that was a lot. I know that there is a lot of different elements at play, so I understand if there's questions. But yeah, I'm open to hear what people have to say. Thank you so much, Alan, for allowing me to do this. Yeah.
Outstanding. Okay, well, thank you very much, Ryan. Really appreciate it. So good information. As you can kind of see, we're really trying to catch Ryan and drag him out to the West Coast someday when he graduates. So perfect. Hey, so I understand that I might have cut off Alex a little bit. He had a short video he wanted to share. I'm going to try and pull that up, Alex, and unmute you and pull that up here just a second, and then see if that works or not. All right, so we just need to unmute Alex and
yes, and I also actually shared the link in chat. I mean, people could view it at their own leisure if they wished.
okay, hopefully we can Okay, Alex, sorry about that. I don't know if you want to provide a little context to that or.
I'm sure, I guess. So basically, the main point here is that our system is able to take cyber threat intelligence, which does include the vulnerabilities currently being exploited in the wild, and associate them with the local vulnerabilities. But a lot of people might confuse a lot of cyber threat intelligence that is available. It actually comes in protocol levels due to the nature of disclosing vulnerabilities. So even though we tested the system with what is effectively level green and white protocols, which is publicly available and it technically older than you would potentially want to use, there is cyber threat intelligence repositories and sources, and even through partners, that is much more recent, or like as soon as they discover it, basically, they do let their partners and know of this, and it's much more relevant at that time as well. So really, our system could take this info and help analysts across the industry and across the board be alerted to these presents in a very short amount of time. Essentially, that's the theory, at least. That's it. I'm done.
Okay. Well, hey, sorry for cutting you off and not getting that on your first pass. And a big thank you to you and Dr. Shin, Dr. Larson, Dr. Elkins, and to everybody really. So some good information. If you need contact information from people, feel free to hit it up in the chat. We can share that. And I think at this point we will, we're done a little bit earlier ahead of schedule, which gives everyone a chance to go grab a bite to eat or drink. We will kick it back off at 11:30. Brendan will be online with us and provide a little bit of context for some of the really cool technologies and experiments that were conducted in Coastal Trident. And then we'll do kind of a similar fashion where we're going to just jump through a couple of the different presentations and let them share with what they're doing and what they've done. So with that, we'll be online here if you need anything, but we'll go quiet and we'll see you guys back here at 11:30. Thanks again, everyone. Thanks for your time and hope to see you here shortly.
All right, it is 11:30, and so we're going to go ahead and press forward with our agenda. Thanks everybody for coming back. Again, really appreciate you guys being here with us today, participating in something new, innovative, a little bit scary, but based on how the research track went in the last session, I'm really encouraged that we're going to be successful at kind of transferring the feel of what we're trying to achieve through the technology open house that we usually get to do in person at the port. Just a little bit about the last track. It's really easy to see how those research projects and all that scientific knowledge translates eventually into physical systems that can be taken out and do things in the port and maritime security world, meet the technical needs of the Navy warfighter. And so we felt that it was really important to share the research projects that we're doing because those are eventually going to fill the pipeline as technologies to the Coastal Trident program and other field experimentation programs. When those research projects become mature enough to be implemented in technologies, it's going to be you, the technologists and the subject matter experts and the companies that are responsible for developing technologies and selling them to the government or to other port and maritime security stakeholders. It's important that you have an awareness about the research that's going on and that you guys are the ones that are going to be innovating and collaborating with those researchers to make those scientific concepts into physical capabilities. So thanks to everybody who participated in that session. And the second session focuses on Coastal Trident and ANTX and the activities that we conducted this year as part of ANTX Coastal Trident 2020. Like I said earlier, it's there's 32 projects in the construct, in the design of the 2020 program. So we obviously can't go through all of them in excruciating detail. If you've ever sat through one of our planning meetings, you know that it gets old listening to me talk about every single project. So I'm going to leave it to the people that actually executed the projects and developed the concepts for them and are responsible for the technologies. They're going to talk in a second. I'm just going to step through a couple of slides that will kind of set the scene. And some of these are, actually almost all of these are kind of repeats from yesterday. But I know just in looking through the participant list today, we've got a bunch of new people that tuned in for today's meeting as opposed to yesterday. So just want to make sure that everybody kind of understands where we're at and that we set a baseline for the projects that we're going to be discussing. Alan, can you hit the next slide, please? Okay, so this slide, again, you saw it yesterday, but it shows the intent of the Coastal Trident 2020 program. It's going to be conducted to examine the operational and technical capabilities of port and maritime security organizations to address asymmetric threats. So again, asymmetric threats, what we're talking about, natural disasters, industrial accidents, terrorism, pandemic disease, cybersecurity, all of those different threats that cost very little or take very little resources to present the threat or perpetrate an incident based on those threats relative to the massive amount of preparedness efforts and resources that it would take to respond to one of those efforts, to one of those incidents. And you know, the reality is that these asymmetric threat environments are never one in which a single agency operates alone. They're always collaborative. They're always multi-jurisdictional, multi-domain, multi-authority. So you got a whole bunch of different people coming to play in these environments, and you know, that's what makes it so challenging. So Coastal Trident 2020 was made up of training activities, field experimentation activities, and in the planning we had a bunch of exercise activities on the table as well. Talked a little bit yesterday about how COVID disrupted a lot of those exercise activities in cases where we couldn't gather in groups of more than 10. But again, just want to reiterate, when we're talking about execution, we're talking about these projects that we're doing. You know, I want you to keep in mind that part of the reason we're reviewing these projects is that, you know, we're going to be soliciting input and, you know, your insight and your feedback for projects that we take forward to the 2021 program. So think of these all as opportunities to build on, to supplement, to work in collaboration with these projects or other projects that we talk about during this session. And remember that our job as the program managers are to create an environment for you to achieve your objectives and the objectives of our sponsors. But these activities really come from you and are communicated by your priorities. So if you've got stuff that you want to do, make sure that we know about it, because all of these projects that we're going to talk about today did that same thing. Next slide, please, Alan. Okay, I talked a little bit about the program design yesterday and how we break it up into modules. And this modular design is really the reason that we were able to execute the ANTX Coastal Trident program this year in the midst of the COVID response and all the limitations on travel, social distancing, large gatherings, because in this modular construct, we're not trying to shove hundreds of people into one place over the course of a short period of time. We take small projects and we time separate them and location separate them. And it's really the only way to do that when you're talking about being on ships, being on bases, being on oil platforms. You just can't, it's very difficult to set up situations where people that want to come observe can in large numbers. So Coastal Trident has evolved over time into this very geographically and temporally distributed project that works really well for getting stuff done. Not so great for visibility, but that's why we have the open house event like we're doing today or this week. Yeah, I talked yesterday also and just a little bit ago, we have 32 projects in the program design for this year. Alan, next slide, please. And this is what that looks like. So each of these numbers that you see is a module or a submodule. We really have 5 different focus areas or major modules. Module 1 is Port and Maritime Incident Response. Those are all exercise activities associated with lots of organizations coming to respond to a major incident in the port or maritime domain. Module 2, Port Security and Critical Infrastructure Protection. So those would be physical security systems, cyber security systems, systems that are designed to ensure, recognize, detect, recognize, characterize, and then cue action based on threats against port facilities or other critical infrastructure on the water side. Module 3, Unmanned Systems Applications. A bunch of different work there in multiple domains, undersea, on the surface, in the air, basically harnessing the capabilities of unmanned systems that can overcome the physical and the physiological limitations of people in the maritime domain. Module 4, again, like I said yesterday, is the counter to that. If it's a good idea for us to use unmanned systems to do things that we want to do, we probably should start thinking about ways to counter them. A number of the researchers talked about unmanned aircraft systems or unmanned aerial systems as, you know, kind of one of the threat du jour. You know, everybody's really worried about that. So what do we do about those threats? How do we counter them? Module 5 is focused on domain awareness and information dominance. And again, if you think of the ocean as a vast desert with a whole bunch of information that we want to access and virtually no infrastructure with which to transmit or disseminate or leverage or exploit that information, then that's what all those different systems are aimed at doing, is collecting that information, processing it, and making it useful, and then sending it out to the people who need it when they need it. Just a little bit about, if you're counting the numbers, I know it doesn't add up to 32, but some of these projects or some of these modules have a number of sub-modules. So take module 4.2, for example, point defense systems for countering unmanned aircraft. That module actually has an A, B, C, and D, where we're evaluating 4 different systems that would be used as a point defense against unmanned aircraft systems. So IXI, who you're going to be hearing from in a little bit, they have a drone killer system, which is a handheld counter-UAS system. Invisible Interdiction has handheld, tripod-mounted, and weapon-mounted systems that are very similar in their operation. Epirus has a high-power microwave or electromagnetic pulse system that we were hoping we would get to evaluate out at White Sands, but couldn't pull that one off this year. And then a project that we have at PhD for looking at the use of shipboard fire hoses to bring down drones at close range. So again, that module 4.2 has 4 different projects associated with it under the same theme. There are a number of those modules that have the same situation. And so you'll be hearing from some of those projects that are working on kind of the same focus area with a little bit different application or implementation, particularly with unmanned systems. Next slide, please. Okay, so same information on the screen, just color coded. The green, blue, and red is kind of the, it's my quick look assessment at what we were actually able to achieve this year. Out of the 32 projects that we had planned and part of the design after the final planning meeting, 11 of them had to be postponed until next year. I think that's pretty good given the circumstances that we're finding ourselves in. And like I said, most of those projects were either large scale events where we just couldn't have all the people that we needed in one place at one time, or they were technologies that were really dependent on that exercise environment. Such as module 5.6 and 5.7. They were really dependent on large groups of people and things moving around and the ability to instrument people that were doing specific jobs with different sensors. So they also had to be postponed as well. That's all I need to say on this slide. Alan, can you go to the next one, please? Okay, just a little bit about area of operations. I talked about this a little bit yesterday. Coastal Trident tends to be focused in Southern California because that's where we're based, and frankly, it's easy for us to access the resources that we've developed over time conducting this program and networking with the port and maritime security communities. So, we have access to facilities, to vessels, to threat representative targets, and so it's very easy for us to conduct the program locally because we have virtually any kind of learning environment that we would want in Southern California. As a result of restrictions on travel or restrictions on movement prior to boarding ships, several of the projects decided that in order to be able to feed us the results that they wanted to have documented and carry forward, and the knowledge that they wanted the port and maritime security community to gain based on their projects, that they would stay home and they would demonstrate those projects locally and then give us the data and allow us to share the knowledge with them. So that occurred in Austin, Texas with Future Tech, Jacksonville, Florida with Teledyne and Martac, both of which you'll be hearing from today, and Camp Grafton, North Dakota with AVT on a area defense system for countering unmanned aircraft. Next slide, please, Alan. Okay, so here's the kind of the finer detail on what we did in Southern California, all the different types of venues that we were able to leverage. And again, I talked about this yesterday. Anybody who's been to the Coastal Trident planning meetings has seen this many times. But again, kind of the bottom line for this slide is I want you to think of this as an opportunity. It's an opportunity to leverage the resources that we are able to amass for an ANTX and Coastal Trident event. And they're very diverse. They're large vessels. We've had vessels as large as 1,200-foot container ships participate in Coastal Trident. They could be military vessels. They could be kind of dedicated research vessels that may or may not be Navy. They could be small boats. Port police or other local law enforcement organizations have a number of small vessels that they allow us to use as targets or aggressors or technology platforms, oil platforms, islands, wildlife refuges. And then, you know, land-based facilities run the gamut from labs to bases to parks to, you know, private sector facilities. So really to kind of take a look at this slide and see the significant diversity in where we operate, what kind of resources we're using there, and you know, kind of chew that over as we're going through all these projects and we're working towards tomorrow where we're going to be talking about concepts for the next year. We really do have a lot of resources and assets and subject matter expertise available to us. And so there's a lot we can accomplish here that would achieve a wide variety of objectives. I like to say that, you know, given enough time, we'll find the resources that you need to do what you want to do. So engage us early and often on new ideas, and you know, you'll see from the results of today's discussions what we're actually able to achieve. Next slide, please, Alan. Okay, so the highlighted projects here, this is just, again, the administrative construct, if you will, or the design, the modular design of the program, same as we've been looking at the past couple of slides. But the highlighted projects are the ones that we'll be talking about today. Like I said, there are several projects under some of these modules that we'll be hearing from, but in no way is this an attempt to highlight projects over others. These were just projects that we thought would be of interest to the community. They've already been executed. We have some of the projects that still are going to be executed before the end of the program on September 30th. So these were the people that we reached out to and asked them if they would be interested in giving us a brief presentation about their projects, what they planned, what they actually did, what they learned, what the way forward looks like for them. And just like the previous research track, I think you're going to find it very interesting, engaging. I think you're going to see that there's a lot we were able to accomplish in the program this year. So congratulations to everybody on that. And hopefully it gives you some ideas on how to collaborate and innovate with these partners or in parallel or on your own or with other partners, and really get some really neat things done for next year. Next slide, Alan. So to go along with the FathomWorks message in the chat, just kind of before we kicked it off, I wanted to make sure that there weren't any other questions about the previous track or kind of the brief material that I just covered before we jump into the project team presentations. Okay, nothing heard. So we'll go ahead and get started. The first project is going to be a collaboration between Teledyne Technologies and Martech. Barry Cross is going to be our presenter. This is module 3.3a. I don't expect that you still have that material in front of you, but I live and breathe it, so I like to talk about it whenever I can. But this module is called Unmanned Survey for Digital Engineering and Infrastructure Assessment. And I'll let Barry tell you about what they did and what they learned.
Well, thanks very much, Alan. Can everybody hear me okay? Okay, I'll assume so. Good morning and afternoon, everybody. I'm Barry Cross, a Defense and Security Sales Manager for Teledyne Optech, and it's my pleasure today to present an overview of the recent collaboration between Teledyne and our partner Martech Systems for Coastal Trident 2020. Next slide, please. Well, we had planned for the exercise to be at Port Hueneme. Due to COVID-19 considerations, we transitioned to a plan B. This allowed us to still leverage the work our team had done configuring the integrated solution and to contribute to the Coastal Trident program through the virtual open house today. Our alternate survey site was Black Creek, which is south of Jacksonville, Florida, as highlighted in the map below. The site is near Martech's facility in Florida, where we had integrated and tested the solution in preparation for the exercise at Port Hueneme. Black Creek is a fairly shallow river with depths up to 25 feet. For the combined LiDAR and sonar survey, we focused on an area with a low bridge to demonstrate survey above and below the waterline. The demonstrated solution is an integration of various commercial off-the-shelf hardware and software products from Teledyne and Martech. And after reviewing these solution components in more detail, we will proceed to view a recording of the real-time exercise that was performed on July 31st. Then, following a brief review of the benefits of the solution, we'll take a look at the fly-through of the resulting data. And we should have a few minutes at the end for a brief round of Q&A. And in the interest of staying on schedule, please hold any questions until that time. Next slide, please. Alan, if you could please advance to the next slide. The hardware components include the Martech Mantis T12 unmanned surface vehicle, the Teledyne Optech CL360 LiDAR, the Teledyne Reson T20 multi-beam sonar, and an inertial navigation system with GPS and inertial measurement unit. The configuration is supported by a suite of software, including the Mantis Command and Control, Teledyne PDS for sensor control and data acquisition, and CARES Onboard for data processing and dissemination, which is all running on the Mantis onboard computer system shown in the lower left. Next slide, please. Before we take a closer look at each of those solution components, we'd like to note that this configuration can be utilized for a range of applications across civilian and defense and security domains. Within civilian realm, this includes survey and engineering, facilities and infrastructure management, as well as environmental and natural resource management. Within defense and security, applications can include search and rescue, situational awareness, and threat detection and monitoring for coastal zones and port and harbor environments. It's also important to note that rather than mere pretty pictures that are shown, similar results from our survey solutions are generated from highly accurate georeferenced survey data, which is critical for supporting this range of applications for engineering and geospatial intelligence. Next slide, please. The selected platform is the Martech Mantis T12. The Mantis product line includes a range of 8 to 50-foot variants, and the 12-foot T12 platform was selected as the right fit, sufficient for the selected sensors we will review next. The Mantis T12 is a mature platform developed over the past 10 years, has been used on multiple defense programs, and is currently considered TRL 9. It is a highly robust and reliable platform with a catamaran hull, provides a very stable, low vibration platform for survey applications. And finally, the Mantis USVs as a product line have fully integrated power, command, control, computers, and communication resources, which enable the overall solution. And this includes the tracker application software for platform command and control that's shown in on the slide. Next slide, please. The Teledyne Reson T20 multi-beam sonar is a high-end, low-swap instrument with more than sufficient depth performance for both Port Hueneme and Black Creek. The T20 was an obvious choice for this exercise. The very high beam density allows high-resolution data over a wide field of view. And while this installation used a single unit, multiple units could be combined for increased survey efficiency. The T20 is also a low-profile system for shallow conditions and can be mounted in an off-nadir orientation to capture data all the way to the waterline in coastal and port and harbor environments. The tracker autopilot feature automatically optimizes all basic sonar settings in real time. This makes the T20 a real hands-free sonar, which is especially important for this type of USV deployment. And finally, in this case, the T20 system included an inertial navigation system with GPS and IMU from Teledyne Reson, which enabled the georeferencing of both the LiDAR and sonar data. Next slide, please. The CL360 LiDAR from Teledyne Optech is a survey-grade LiDAR suitable for use on UAVs, mobile terrestrial platforms, as well as surface vehicles such as the Mantis T-12. Survey-grade accuracy enables the use of resulting data for professional survey and engineering applications. With up to 4 returns for each laser pulse, the CL360 provides an incredible sample rate of up to 2 million points per second. This translates into high data densities and overall feature survey efficiency. In addition, the very narrow beam divergence of the laser and the laser power itself enables small feature discrimination and data capture at ranges up to 775 meters on low reflectivity targets. Next slide, please. Teledyne PDS is an acquisition software package, provides command and control as well as pre-processing of data from the sonar and LiDAR instruments. It has a configurable user interface and for sensor configuration, control, and real-time visualization of the data collection. The upper right image is the real-time view within PDS, showing the platform location and orientation along with decimated LiDAR and sonar data, providing real-time confirmation of system operation. Next slide. Through a seamless interface, the data acquired in PDS is then further processed in Teledyne Keras on board. Using a process automation designer, automated workflow routines can be tailored to the sensor configuration and to support both real-time monitoring, QA/QC, and end-use data product needs. Specifically, processing data with Keras on board provides the ability to view near real-time data results via a browser from remote locations. This enables an improved QA/QC process, which enables in-field corrections to the survey data collection activity, thereby minimizing costly revisits. Also, processing on board provides actionable intelligence in near real time to remote users and reduces the processing backlog for generation of final information products. Next slide. So now we'll take a quick look at some clips from the live exercise that was conducted on July 31st, when we held both morning and afternoon sessions online, drawing a total of about 250 attendees. As you can see in this scenario, the USV was controlled by an operator on a nearby pontoon boat using the manual control feature. The system can also be controlled in semi-autonomous and autonomous modes, but this was consistent with the plan that we also had for Port Hueneme. The next slide, please. Before we proceed to view some clips, I just wanted to recognize and thank the members of the Teledyne and MarTech team that pulled this Plan B exercise off on short notice, and to also thank Brendan Applegate for his support and engagement and for providing the flexibility to accommodate this change of our plan. Alan, if you could now please advance to the next slide and play the video, which briefly reviews the command, control, and data processing application during the real-time exercise on July 31st. There should be sound. You have to advance the slide one more. Should play.
And prop control. Right now, Sean is driving it in manual mode. It's a manual operation. We have the ability to control the vessel in manual where you're just driving it, you know, when you have rudder control and prop control. We also have what's called semi-autonomous mode where you basically set a waypoint and the vessel, we'll go there. Sean just set a waypoint, so now it's in semi-autonomous mode, and off the vessel goes. It'll track right to that line. And then finally, we have a full autonomous mode in which you can pre-program missions. We support patterns. So for example, the classic zipper pattern of mowing the yard, the Mantis will go back and forth, and at the beginning of every path line, it will align itself and it will track accurately. We have proprietary software that's highly accurate and generally will stay within a meter and often a foot or two of the path line, depending on, of course, the day and the current level and all of that.
That's the 2D view. That's basically set up so you can do your planned survey. You'll be able to put background layers like charts or run lines. There's a lot more different views as well that you can use. So we're just using these two for now. The viewer above that one is basically the raw data coming from each individual sensors. We can keep track of all sensors and make sure they're all functioning properly. One of the key benefits to this application that we got going on here is the tracker mode. Tracker mode is basically like an autopilot mode that it uses the bottom detect algorithms to properly adjust all your settings so that the sonar basically runs itself. It'll set all its range, its transmit power, its gain, everything for you. So basically you can just reduce this display and let the sonar run by itself.
So we've just seen PDS collecting the raw data, and Keras on board is taking that raw data and using the predefined workflow I talked about earlier. It's creating the processed multi-beam and LiDAR data that is properly georeferenced point cloud and corrected for sound velocity and vertical referencing. What you're seeing right here now is what's different from what we just seen previously through the web browser interface, which is serving up essentially a reproduced image of the data. This is actually looking at the processed georeferenced point cloud in our desktop application. And that allows us to do further quality control and analysis on the data. In this case, you're actually opening up the process data coming straight from the onboard project files. So you have same time real visibility as a web interface, but with more powerful tools available in the desktop Keras application. So as you can see here, you've got some really good detail on the bridge pilings, both above and below the water from both the LiDAR and the sonar at the same time.
Right now, Sean is driving it and
So you can advance to the next slide, Alan. Thank you. So next, we'll take a look at the final data results. But before we do, I just want to do a quick review of the solution benefits. First, this particular configuration provides for survey both above and below the waterline using the Teledyne CL360 LiDAR and T20 sonars, respectively. This is useful for coastal and port and harbor environments where there are significant infrastructure features. Second, deployment on the Mantis T12 USV improves accessibility to shallow areas and offers the potential to minimize operational costs through autonomous and semi-autonomous operation. Third, Teledyne PDS and Keras onboard software enable real-time data verification and quality control, further improving efficiency and minimizing costly revisits. And then finally, although the Mantis and Teledyne together can provide other platform and sensor configurations with our respective commercial off-the-shelf products, the small USV survey configuration is itself scalable through swarm deployments to achieve wide area coverage and larger program needs. Next slide, please. So next, we'll take another quick look at the final data results. As we fly through, please note that there's an enormous amount of data collected in just a single pass through Black Creek. For example, please note the detail in the image on the right of the docks, bridge understructure, and power lines, as well as the subtle details of the riverbed, particularly on the shoreline area on the right. Again, note all this data is georeferenced and survey grade. And before we go to the video, please note that the full recorded webinar from July 31st is available at the site below, where you'll be required to register to view a recording which runs about 35 minutes. As we proceed, I will also hand it back to Alan or Brendan to field any questions, which I will try to answer as we view the fly through. And then time permitting, there's yet another video that takes another look at the PDS real-time data collection. So Alan, if you want to please go to the next slide and run the fly through, please. So you can see quite off in the range, the LiDAR was able to reach pretty far from the survey location, for example. And again, you can see a lot of the structure that was captured of the docks, and then also the understructure of the bridge and the power lines. And there is a lot of gaps in coverage. Were we to run this again, we would basically plan a survey path which gave us complete coverage. And then in addition to that, we did run a nadir orientation of the sonar. And so we really did not get sonar data right to the waterline in a lot of cases, which is resulting in a lot of the voids in the data coverage that you're seeing. But with those two simple changes, we were able to very quickly capture very high quality information using this system.
Excellent.
Brenda, did any come in?
I haven't seen any questions. Yes, I actually just saw one from Jennifer Elliott. How long does it take from surveying to site to processing the data, and what operating system or speed is preferred for the laptop?
Well, again, really, we were running everything here in real time on the onboard computer system of the MARTAC platform. We were basically using a cellular data connection, and we were largely using a terminal server type of approach to view the onboard computer system. So there was no, in this case, no transfer of the actual data off the platform, but provided the additional bandwidth, which can be provided with different communication options. That would also be possible. As far as the operating system, I believe that these were Windows PC-based systems. And it was only the standard computer that MARTAC offers with the platform, as opposed to any special provisions. I hope that helps. If you'd like more information, Jennifer, please just drop me a line.
Great, thanks. We got another question from Professor Clark. How does this work in any sea state or CHOP? So would it work in open ocean?
Yes, it will. I guess I go back to selecting the right platform for the application. Again, MARTAC has a range of platforms all the way up to 50 feet, as well as Teledyne with a variety of sensors for different environments. With that said, the Catamaran platform is very stable. It is submersible even. It has the integrated electronics bay that protects the electronics. And so, it does have a fairly robust capability relative to coastal conditions.
Great. Judy Isbell asked the question, is the survey platform limited as to the temperature in which it can operate? For example, extreme cold.
Well, I would first say, obviously, it's not an icebreaker. So, but barring that, no, I think all the sensors are very robust. The Optec LiDAR, which is the one exposed sensor, it is marine grade, and so it's rated for salt spray, and also I forget exactly what the operating range is, but I believe it's to -20 or something to that effect. Maybe -10.
Okay, follow-up question from Jennifer Elliott. How is the platform shipped? Does it come apart to fit into Pelican or hardened cases?
Well, and so a lot of components came together for the solution. And I believe our plan for shipping this from Florida to Port Hueneme was basically to include the sensors in the shipment with the platform. I would have to confirm that, but generally, you know, it would be an option to also ship the sensors in a Pelican case along with the platform. The platform
that
was
would
something
just...
that...
Sorry, Barry, go ahead.
Well, the platform was something that MARTAC was taking care of in terms of its transport. But the sensors can easily be packed in Pelican cases and reconfigured or installed on site.
Okay, Barry, thank you so much. Really appreciate you putting that presentation together, talking about what you guys have done. And I know we're looking forward. We've already got plans in the works for 2021, so looking forward to what we're going to do there. One of the things that you didn't cover in your presentation was the use of an amphibious unmanned aircraft to supplement with imagery from the air. So I believe that's part of the plan for next year, is to be able to include that element and just augment and increase the quality of the data that your systems are putting out. So really looking forward to seeing that, and we'll get planning on that soon.
Yeah, thanks everyone for your interest. Please do reach out to me if you have additional questions and if you're interested in how this type of solution can be applied to your needs. Thanks, Brendan. Thanks, Alan.
Thanks, Barry. Okay, next up is going to be Stephen Conklin from ViaSat, and he's going to be talking about module 5.4a, which is, again, I don't think you guys still have that in front of you, but broadband satellite systems for maritime communications. For a number of years, we've had local law enforcement, specifically the Long Beach Police Department's Port Police Division, asking us about how they can send data back to shore when they're out doing small boat operations outside of cellular or radio range. They have a need to send pictures, video, data. They just don't have the systems to do it. So like we talked about earlier, those kinds of organizations don't have a formal interface to the science and technology community, but they are participants on a recurring basis in Coastal Trident, so that they know that we have a large network of people who provide really unique, really specialized, really capable technologies that we can hook them up with so that they can evaluate it to see if it meets their needs. So that was our initial objective in engaging ViaSat about broadband satellite comms. And I'll let Stephen Conklin tell you about the rest of the project.
All right, thanks, Brendan. Can everyone hear me? Okay, I'm going to assume that is a yes. So yeah, thanks. I want to thank Brendan and Alan for letting us come and have a conversation with everybody for a second. So what I'd like to do is just give you a quick little overview of who ViaSat is, where we were located, what we do. We do broadband satellite communications, but we also do a lot of ISP work and security work. Not just over the broadband satellites, but we take a whole holistic kind of approach to how you can get the kind of capability and networks that people are used to having now. We live in an environment now where everyone's used to having their cell phone with them and having instant access to a broadband capability. That's only going to increase whenever you have 5G networks rolling out. And so what we like to do is specialize and be able to give the user community the ability to have that same experience either from your home office or your office or on your cell phone anywhere in the world over our satellite constellation, and then over line of sight or LTE or other systems that we bridge over in a concept called hybrid adaptive network, where we like to put the user over the best available network available, whether it's our network or someone else's network. Because at the end of the day, what the user really wants it to be is seamless and easy to use. And so we try to do that with our setup. So what I'll try to do now is just kind of go quickly through some quick slides about how we do that. And then I'll talk about the August 7th event that we did on the Atlas, where we took one of our broadband systems offshore in Ventura County, and basically spent several hours out there doing streaming video, BTCs, just showing capability to the crew. So next slide, please. All right, so ViaSat at a glance, who are we? So we're based in Carlsbad, California. We have offices around the world, as you can see from the list there. We have an annual sales about 2.1 billion, roughly around 5,600 team members. We started in 1986. We started out doing mostly security modules, small kind of VSAT systems for government commercial users. And as we quickly developed as a company, we realized that if we wanted to provide the experience to the users that we were looking for, we had to get much more integrated when it came to doing security, when it came to doing controlling of the satellites themselves, the ground infrastructure, to tailor it to the way we thought we could make it and have the offering we wanted the customers to have. So right now we have 4 satellites in orbit. I'll walk you through those satellites. We have another fleet of satellites going up in the next couple of years. There will be terabyte satellites, and I'll talk about those as well. So next slide, please. All right, so as I stated earlier, ViaSat believes that everyone and everything can be connected. So what you see highlighted here on this slide is the markets that we actively are engaged in right now. That includes community Wi-Fi, government, in-flight, smart city, like connected cars, home internet, and then maritime, of course. We are integrated in most of these areas because there was a need to have a better connectivity. We've made a lot of great success in in-flight with American Airlines, United, Qantas. From a commercial standpoint, we also support government users. We support the blue and white fleet, which is the presidential fleet, so Air Force One. So we provide them with broadband connectivity when they're in service throughout the globe. Maritime, we have about 4,000 vessels that are on, mostly smaller vessels. We are doing more, pivoting more towards maritime. So we see an opportunity with the Coastal Trident event to come in and show what our capability is to everybody and to just get our name out there. We are relatively new in the maritime area. But as you can see from this slide, we have been working in the other areas that have a really good cross-thread over, that we can basically take what we've learned from those areas and use them in the maritime community. So next slide, please. All right, so again, we take an enterprise approach. So that includes not only the end user device and applications, we're concerned about how those are met, how those are worked. We provide information assurance from a security standpoint. Then we have multiple types of terminals. We have maritime terminals, fixed terminals, with aircraft terminals, and then home internet terminals, residential terminals. Those go to multiple satellite access gateways. We believe in what we call the HAN experience, which is a flexible networking. If the best solution is to put you over LTE or over SATCOM, we'll put you over whichever one is the best solution at that point, and we can tailor that on a per applications basis. And then we practice an enterprise management and control kind of concept and can connect into open internet. We can go into DODIN, we can do secure, we can do unsecure. So we try to run the gambit of what we believe is important. We believe all these certain areas all tied together is what will give you the best experience, our customers the best experience, and that's what we're striving to show with these demos and then with our capabilities. So next slide, please. All right, so ViaSat as a whole took a fundamental look at how traditional satellites were built, and we decided to build satellites a little bit differently. So as you can see, there was a transition from like a single broadcast cell tower to multiple cell towers, and that was really revolutionized on how wireless communications were achieved. Well, we looked at a standard setup on how most traditional satellites are built, and as you can see on the left-hand corner, a traditional satellite would have a large coverage area. It would be a single beam over, say, a continent, and then you would be limited in some capabilities based on what part of that satellite beam you were in. So we thought about this process and decided to build a satellite system that uses more of the cell tower kind of approach. So that allows us to do a lot of different things. It gives us a broader coverage area. It allows us to provide more power and more bandwidth on a per user basis because we can do things like frequency reuse. And it also allows us to have better security because now if you have someone like a denial of service attack or someone trying to do a jamming within your footprint, typically on the left-hand side, they could be anywhere within that footprint and they're really hard to find and designate. But with the smaller footprints that we'll show you, the spot beams, they're really isolated down to having to be much closer in to have some kind of impact on the user at that point. So some further slides will kind of show you details about that. So next slide, please. All right, so as I spoke a minute ago, our satellites use more of a spot beam concept. So what you see here is this is multiple spot beams over the United States that we have on our ViaSat 2 satellite. So there's a couple of things that we can do with this that really from a technology standpoint that's really helps us get into more of a broadband service experience than what you would traditionally get in, say, the WGS birds or the older satellite models. We have the ability to take frequency and reuse it. So that allows us to basically use the same frequency over a number of times within each of the spot beams. We also are allowed to use, we can take a single amount of power that goes on each of those spot beams. If you're familiar with how satellites work, you have the power on those, and then usually that's spread across a large beam. But since our beams are smaller and we're using spot beams, the power is now more isolated into certain locations. That allows us to give better throughput based on using better waveforms. So this is just kind of a conceptual of how we can use that spot beam to do frequency reuse, and then also, you know, with this frequency reuse, you get kind of a you're going to get inherent interference issues. You have millions of those sources. So what we've done in our satellites is we've built in the capacity to be able to mitigate the interference, so we can reuse the frequencies without having any chance of bleed over. So next slide, please. All right, some other benefits for this. So as you can see, the satellite basically gives you some other inherent availability. It gets better availability because you have more spot beams and we can switch over spot beams at any time. You get resiliency because of that. And then we have the anti-jam that I was just talking about. As you can see at the very top, the traditional satellite, you can see it's a much wider beam. If you look on the right-hand side of the top picture for ViaSat 1 beam, that did not use the spot beams. That was one of our satellites. We put up our first satellites that we put up, and it had a much broader wide beam. So it had good coverage, but it didn't share some of the benefits of the ViaSat 2 satellite that we use for this operation. You can see at the bottom of that, you can see that same kind of coverage area now with all the separate spot beams. So you get a greater use, it's more resilient, and you're able to, this is what allows us to be able to provide these broadband capabilities, and I'll show you those speeds a little bit later when we talk about the Atlas test that we performed. All right, so next slide, please. So just in general, real quick, this is our ViaSat 2 satellite constellation that's over the North America, and it covers the shipping lanes between North America into Europe, and it goes all the way down to South America. As you can see in each of those areas, those are all the spot beams, and traditionally when you think of a spot beam, you think of a really tight spot beam, and we have different size spot beams. These are the wider spot beams that we use, but we also have smaller spot beams, and in that case, we can overlay those if we need to. So just generally, this is kind of the footprint to kind of show you the capability and the coverage area that we have with this satellite that's up right now. So next slide, please. So our K-band satellite fleets involve a couple of things. So we built so we have ANTX F2 that we're using, a Wild Blue 1. We built modules that use those satellites for our Wild Blue, which turned into which is now our ViaSat home internet constellation. And then we brought up in 2011 ViaSat 1. So that was a 140 gig satellite. It covered all of North America. And you see at the beginning of these satellites, most of them covered North America because that's where the high usage is. So starting with ViaSat 2, we went to more of a regional coverage. So with regional coverage, what I mean by that is it's a 260 gig satellite, and it covers all of North America, but also goes up close to the polar, goes down to South America, at the tip of South America, and then it was important for us because we're doing a lot of work with airlines and with the shipping lanes, that we covered the shipping lanes between the United States and to Europe. So this satellite covered that. So our next satellites, which will be roughly 2021, 2023, is a constellation of satellites. These will be terabyte satellites, and they plan to be a global coverage for KA. We do have KU coverage that's global right now, but the KA is more isolated to North America, and then Australia, parts of South America, and then over Europe with our KA-SAT partnership. But we will, by 2024, have the global coverage down to down across the globe for all these KA satellites. All right, so next slide, please. All right, so right now, this is our current coverage and capacity. So you'll see that we've got KU band and KA band. So we've got roughly around 5 gigabits per second of coverage right now. So if you go to the next slide, when we put our first ViaSat 3 satellite up, that's going to cover, again, as you can see, the coverage there will cover North America, down all the way to South America, up to parts of Canada, and then spread over the same shipping lanes that we're looking for. And that is going to increase 3 times the bandwidth that we have now, so roughly a little over 1.5 terabits per second of data. And then next slide, please. So 6 months after that, 6 months to 12 months, and things vary, especially with COVID-19 right now, we'll have another ViaSat satellite up. That'll be over the NEMA areas, which will include all of Europe, Africa, the Middle East. And then that's going to increase us up to anywhere about 2.75 terabytes per second of bandwidth capacity available. That includes all our ViaSat KA and our KU. And then next slide, please. So by 2023, we will have the global coverage. That is going to give us greater than 3.5 terabits per second of coverage globally, which will cover all shipping lanes. As you can see from the maritime perspective, this will be very, this will be something that we're really interested in, and I think we'll have some users that will be, because there's a lot of areas where Inmarsat is the only kind of user capability in the middle of the oceans. That will be changed when these satellites go up, and we'll be able to provide a broadband capable solution for that. So next slide, please. Okay, so that's enough with the BD stuff. I'm due, so I forgot to introduce myself. I'm sorry. So I'm more of a product engineer for ViaSat, working on the maritime platforms and applications. So I work with all the demos. We've done a number of events for Coastal Trident. This is our first year where we actually got to bring some equipment out and bring it offshore. We were supposed to do a demonstration onshore and then offshore as well, but obviously with the open house being canceled, we didn't have the truck there, we didn't have the equipment, so we took advantage of this opportunity going to the Atlas. So we brought out a 60 centimeter KA SATCOM system. This system is using the Cobham Sailor 600, which is a pretty industry-wide produced antenna that Cobham does. It has our components integrated into it. It's got a component called a TRIA, which is a transmit receive integrated assembly that includes our buck, our LNB, all the components we would need to be able to connect to the satellite. And what this satellites do is so that allows us to connect to the satellite system. So we brought this system out, we put it on a pallet, we strapped it down to the Atlas, and then we ran offshore for several hours. It took us a couple hours to set everything up and get running, and we get integrated into the nav system on the ship. So we went offshore, we were running 3 800 kilobits per second streams from the vessel back over the satellite to a location on the port that we have set up. You can see at the bottom. We had one port camera that was running there that was being sent from the port back over the stream to the vessel itself. So we had a total of 4 streams running. We also had SA and COP running with WinTAC. If you're familiar with WinTAC, we had chat, we had VTC going, and we were exchanging information between the 2 sites. Next slide, please. All right, a couple more pictures of underway. You can see where it's strapped down on the deck. It's a single cable that runs into the component, the below deck equipment, and that has an ACU and it has the modem. And then we put a router behind there so we can do some connectivity checks. but that's the basic setup for the system. So we had all 4 streams running. We did have a line of sight system on the network, which was called a trellisware. With that, we bridged body cameras off of those line of sights, and then we bridged that into the SATCOM and then pushed it over to satellite. So you can see at the bottom, we had the vest on. We had EUDs that basically were running videos that were then pushed into the trellisware radio that was connected to another trellisware radio on the SATCOM system and then pushed over to satellite and back down to the port so they could get visibility. So it provided command and control. It allowed the user on the port, say the command, to watch what was going on real time on the vessel with body cams and with the vessel itself to make, to make decisions on what to do next. This was something that we've done a lot, discussions with the Coast Guard about their LEDIT teams on how they can do drug interdictions, how they can do vessel boarding and basically checking to see what's going on and get a real-time feed of what's going on, so that we were trying to show that capability here. Okay, next. All right, so here's just another picture. So here's the speed test taken from the vessel. So we got 75 down on the forward link, and then up on the uplink, we were doing 23 down. That that allowed us 23 meg. That allowed us to do all 3 of the cams. That allowed us to also bring the cam back over and then allowed to do other things. There was browsing on the ship. We had a hockey game playing in the background just for the crew. Different things just to show the capability to kind of exercise the bandwidth. Below is where our path was, how we went out and came back in. So yeah, so next slide, please. All right, so this was the network design that we proposed that we would do for the self-defense ship. Obviously with COVID, that didn't get a chance to happen, but we did exactly the same setup here on the Atlas. The only difference is if you look down at the bottom of our network diagram there, where the truck was, that was the actual antenna on the Atlas connected to one of our portable systems that we have on the shore. So it was ship-to-shore communications and control with the trellisware line of sight lined in. We can bridge LTE, we can bridge cellular, and we can do line of sight. Just depends on what the user wants to do. Next slide, please. All right, so future plans for Trident, Coastal Trident and beyond. So we are developing an 18-inch roll-on, roll-off COTM system. We realize that that 60 centimeter, and we also have a 1.1 meter. We understand that those are too big in some cases, especially when we talk about some of the drug interdiction ships, when we talk about some of the police and fire and their coastal kind of requirements for bandwidth, but they still want to have the same kind of bandwidth. So we're developing an 18-inch COTM system that won't have any configuration required, no pointing required. There's no alignment and no calibration. It'll support KA and KU. It can operate or land in sea. So it'll be designed to be able to be put on the back of a truck. You can use it underway on the truck. You can take it off that truck, put it onto a vessel, say a small ship, and then basically go offshore with it and still use the system. It's powered by 110, but we'll also have some options that we can add, and I'll show those to you in the next setup. We were meaning to show this system at the Coastal Trident event. However, with COVID, we kind of got derailed a little bit with that. So this is still finishing up. We will have this system available to show for the next Coastal Trident event and for any other future opportunities. The kit's roughly around 80 pounds. It has magnets, so it can mount to the deck. It can also be strapped down if needed. Next slide, please. All right, here's some other things with this, the roll-on, roll-off system. We think this we're development to be solution for certain things, including Special Forces, Coast Guard, disaster relief, Army, Marines, small harbor patrols. Some of the options that we will be able to do with this system is we can take Link 16, which is another line of sight waveform, and integrate it in. We can integrate trellisware, MANA, and we can integrate Wi-Fi into it. It does have the magnets. It does have the option to do a battery, which can do 5-hour battery. We can go with a bigger battery to give it a longer power range, but the weight would be changed slightly, obviously, because we can not do that with the 80 pounds right now. So this is what we're looking to do in the future. We're looking for opportunities to be able to kind of show off this capability. I think that was the last slide. Was that not? Oh, sorry, one more. Okay, one more slide. So along with Coastal Trident, we participate in other ANTX events. We have been selected to participate out at the ANTX 2021 event out at Camp Lejeune. We will be taking the G18 condom kit out there for this. This is the information that we provided for them when we did the write-up for that. I felt this was good information to provide everyone here. If you're interested in this kind of a system, it's got some of the capabilities, the frequencies, the G/T, or things that most people would be interested in these kind of platforms. So with that, that's kind of what we did for Coastal Trident. We felt pretty good about the opportunity to go out and do it. I felt that it was pretty successful going offshore and doing the work. So we're looking to be able to do more of this kind of capability assessment with everyone else. So yeah, thank you.
Thanks, Stephen. Really appreciate it. I've been monitoring the chat. Dr. Donavon from UMKC had a question about resilience against EMP, high altitude EMP, which John McCann from your team already answered in the chat. But Mark Perez has a question. It says, double or triple your bandwidth with Riverbend steelhead devices. They're used in OneNet installations.
Okay, not familiar with that device, but I'm definitely be interested in hearing about it. So yeah, so great. Just reach out to me on that, Mark, and yeah, I'd love to hear about that. Can I go back to the other question? Yeah, so I know John answered that, and I appreciate that, John. Yeah, so these are GEO satellites. So they are not impacted by EMP. We do have the capability to bridge between MEO, LEO, and GEO satellites, and we do have that. So what I would say on that EMP, what we like with the hybrid adaptive network kind of approach, and that was a whole nother set of slides that would take more time than I was given on this. We have the ability to move the satellite system to the best available network. So let's say you're running over a GEO network and a LEO, and that EMP attack does hit. We can move you seamlessly over to the GEO network, and you would still continue to have communications and control without being impacted by that EMP.
Great, thanks for answering that. Todd Jacobs with NOAA, and I know that we experienced this on the test that we did aboard the Atlas. How high above the deck does your satellite antenna need to be mounted? Will the cabin or superstructure of the vessel leave a blind spot if not mounted above?
Sure. So yes, Todd. So the answer to that is we're like any other satellite provider. We want our antenna as high up as possible to mitigate any blockage situations that may happen. What we do have built in with this system that we used on the Atlas was a built-in cellular router and system. So in the event we got a blockage, it would switch over seamlessly to cellular if we were in the coverage area, and then you would be able to work. Continue to work. You would not see any impact on that. You would see a missed ping or two, but then the application would continue to work. The streams kept working, and we tested that out during this event. Ideally, we would have, in most cases, you would have multiple satellite antennas where you could get around the blockage zones. So essentially, you can't get past the superstructure. The superstructure is there most of the time. So what we like to do is put a satellite in a location where if it can't be high enough, we'll put two satellites, and we do have the capability with the system to be able to have it switch between the two satellite the antennas seamlessly for the user. So both antennas would be tracking. If one goes offline, the other comes online and runs. So that's really kind of the mitigation you can do with that. Then we can also, our system, it has the ability to track multiple satellites, so it would rotate over to another satellite where maybe there potentially isn't the blockage from the superstructure.
Awesome, thank you. That's all the questions that we have in the chat. As always, feel free to post follow-up questions if you have them. We're going to move on though. Thanks, Stephen. Appreciate you.
All right, thanks, guys.
Okay, next up, we've got Kurt Jones and Kelly Martin from AT&T talking about Module 5.2, which is Distributed Antenna Systems Supporting Regional Command, Control, and Communications. So this is their FirstNet Extended to Ship system. And Kurt, go ahead and take it away.
Hey, thank you, Brendan. Good afternoon, everyone. Appreciate the opportunity to talk about our testing today. And right off the bat, many thanks to Brendan, Alan, and the entire ship self-defense team across the board, right? We wouldn't have been able to execute this without your assistance and guidance along the way. So thank you very much. Additionally, AT&T has partnered with CommScope and Nokia for this effort, and they've been great partners. And again, couldn't have done it without all the work and contributions they've made. So thank you very much. So what are we doing? So communications on board vessels have been limited to radio communications, hierarchical yet dynamically reprogrammable architecture, Hydra, say that 3 times fast, and ship-wide interior wireless communication systems, or SWICs. But they lack interoperability with shore-based communication systems, whether the ship is at sea or pierside. That lack of interoperability becomes detrimental when a berthed ship requires first responders to come aboard and assist with emergency events, and the first responders can't communicate with the crew in any kind of effective way. So taking on this challenge, our team's solution enables the following capabilities for the fleet. We put an active DAS on board the ship for LTE capabilities supporting radios and mobile devices, enabling access to FirstNet upon ship arrival and via connection to the AT&T domestic core for first responders and onboard ship personnel via mobile devices. We're providing a pathway to smart ship via 5G core and NR upgrades to the system. And then finally, possible future mobile access to shipboard voice and data systems like JDial and CANES. Next slide, please, Alan. So for this proof of concept, the shipboard installation included a CommScope ERA CRAN antenna system, LTE core, a radio access node to provide LTE band 14, which is FirstNet redistribution on board the ship, a Nokia single band outdoor band 14 small cell for connected mode test, and then a Kumu Relay 2.0 with LTE UE based relay for backhaul in the connected mode. The system is designed to distribute UHF land mobile radio SWICs radio signals. However, we did not install or test that capability on this deployment since there's no LMR system on board the self-defense test ship. However, that is a feature that is on all of the operational ships. Compact core and baseband unit are installed where the ERA CRAN antenna system, and when in port, the ERA system and BBU are connected to the AT&T network via backhaul circuits. When out to sea, the compact core network is activated and provides a closed LTE network propagated throughout the ship. This design enables tablets and mobile phones to work as if they were connected to the AT&T network. The ERA DAS also supports and could possibly replace onboard leaky coax system that is now supporting SWICs and Hydra systems. And that would evolve, take us kind of that next step in the evolution into one consolidated system supporting both LMR and LTE services, both at sea and in port. Next slide, please, Alan. So you've got a picture there of the propagation map that we had predicted for this event. The design coverage for 3 spaces, the crew's mess on the main deck, the wardroom on the 01 level, and the pilot house on the 03 level. Now, our design standard was to meet or beat neg 95 or better. And we were able to do that, and we'll see that here in a little bit. And ultimately, AT&T is leveraging the success of the wireless maritime services, of which we're a joint venture partner which brings service to commercial cruise lines, which is a similar but not identical environment. This is our first foray into doing something like this. Next slide, please. So here's the testing scenarios. What we did, we basically in 2 groups. The simulated at-sea disconnected testing was done using band 2, 1900 megahertz, and the in-port connected testing utilized band 14 at 700 megahertz, and as well as band 2. As you can see from the results, we were able to successfully meet each of the objectives. However, and this is an important point because we needed assistance on that, due to restrictions associated with photography and videography on the ship, the video streaming testing was not conducted, unfortunately, as indicated on the slide. But based on the overall results, however, we have every reason to believe that the video streaming would have been successful based on the signal strength observations. Calls were made in both modes, on and off the ship, as well as demonstrating push to talk. Working with external agencies, local first responders that attended the demonstration, we successfully included them and their devices in the communication architecture. Additionally, we successfully demonstrated the ability to communicate via phone or app, group chat, and calls with personnel on the ship, adjacent to the ship, and across the nation. This is the breakthrough that provides a path for afloat ashore interoperability for emergency response and potential DISCA and HADR activity. Next slide, please. So how about some numbers to go with kind of that verbal stuff? Again, the problem that we were trying to solve was bringing LTE coverage inside the skin of the ship, inside of a steel box, and to establish a communication path for voice and data that supported interoperability of Navy personnel with first responders. As you can see, with the exception of the pilot house, which had some minimal pre-existing LTE coverage, the AT&T, CommScope, Nokia team brought coverage where there previously had been none, and to areas which are typically areas where collaboration takes place, i.e. the cruise mess, wardroom, and the pilot house. The chart on the left highlights the signal specifics. Additionally, and as you can see, we beat our neg 95 at all points there. Additionally, we were able to demonstrate good carrier to interference noise ratio with results of greater than 15 at all locations, and usually well in excess of that and routinely around 50. Finally, on the right-hand side, you can see some of the screenshots of speed test results that were captured on a FirstNet device. In this case, I believe it was a Galaxy S9. Next slide, please. So what's a demonstration without some pictures, even if you're just talking signals? So on the left-hand side, you've got a picture. Thanks, Brendan, again, for helping us out with that part of the Intrepid app, which was one of the applications that's in the FirstNet library. And in this one, the Intrepid app is critical to creating a common operational picture. And in this case, you can see where the number of the test devices were either on or near the ship during that particular test session. And the picture on the right, taken in the cruise mess, very clearly the system was up and operating because the 3 people that had phones out, not me, all had them out and are heads deep into using their phones in the cruise mess. Again, well inside the boundary and the skin of the ship. So again, we appreciate the opportunity and all the support that made this a successful demonstration. We're moving on to the next step, which is taking an expanded version of this, and we'll be demonstrating during Trident Warrior. So with that, if there's any questions out there.
Thanks, Kurt. I don't see any questions in the chat right now, but I just want to kind of re-emphasize some points that you covered. We've been running Coastal Trident on ships since forever, it seems like, and one of the first lessons learned from any exercise we run on a ship is, geez, I took my radio on the ship, and as soon as I stepped through that hatch, I couldn't talk to anybody. So this is, one step in the right direction of providing that capability to communicate exterior to the ship to first responders. But also, if you imagine the defense supportive civil authorities roles that the Navy has for major disaster in the United States, you bring a whole bunch of first responders onto the ship to set up a command post in the well deck or in the crew mess or in the wardroom, and they can't use their FirstNet devices outside of the, inside of the ship. So all of the communication systems that they have procured and rely on to keep them connected to their chain of command and their people out in the field won't work on the ship. So they got to go out on the weather deck and talk. They can't bring their laptops around. It's a really, really unique challenge. So we were pretty excited to see this FirstNet Extended to Ships program come online, and really, really interested to see where it goes from here. I do see a question. It looks like it's from Steve Conklin at ViaSat. It says, how far offshore was the self-defense test ship and what's the coverage area? Kurt, you can talk to that.
So for this test, we did this one in a import mode. So we were connected to the local cell system. Next step, when we go to Trident War, we will be taking it offshore. But the design of this allows it to function by itself. And next, as Steve, with ViaSat, one of the next evolution things that we're looking at is communicating at sea, via satellite.
Excellent, thank you. Any other questions for AT&T, CommScope, Nokia team? Okay, thanks, Kurt, really appreciate you.
Thanks, Brendan.
Okay, so the next project that we have that we were gonna cover is IXI, and I'm getting texts that John Carter from IXI is on. I don't see him in my list, but I may be mistaken. Alan, do you see John Carter? Okay, we're going to move to another project then. Module 5.5, which is Biometric Authentication for Shipboard Information Systems. Liping Chen is with the Naval Surface Warfare Center, Port Hueneme Division, the Air Dominance Department, and she's been working with DISA, the Defense Information Systems Agency, for quite a while now on what's called assured identity, or continuous multi-factor authentication. So she's given us a great video to watch that introduces the concept, and then she's gonna give us some remarks after that.
I'm just going to stop for coffee. Go for Newman. Yeah, that sounds great. I'll transfer the funds now. Hello? 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 Go for Newman. Yeah, sounds good. Okay, yeah.
Hey sir, I've got some information for your mission today.
Ready to receive.
Intel suggests that we have some potential enemy activity in the area. I have some live UAV feeds ready to send them when you're ready.
Send it. Comms check.
Read you loud and clear, sir. Roger, got you loud and clear.
Roger, over. Let's move out.
Sir, Intel suggests you have unidentified object up ahead, 300 meters on the left. Recommend you proceed with caution.
My device is picking up something ahead. Switching to AR goggles now. I need UAV support ASAP.
Sending UAV feed.
Receiving feed. Sending data now.
Roger, sir. I received your upload. You validate at this time that it is an IED. Recommend sending an EOD team. Come on home.
Great save, team. Thanks for covering our 6.
Go for Newman. I'll be home soon.
Okay, Leaping, I think we have your video and you should be unmuted. Can you hear us okay?
Yes, can you hear me, Alan? Thank
Outstanding. All right, over to you.
Okay, thank you. Yeah, this is the video that have different devices there, and DISA has been working on the assured identity for the last couple of years, and been collaborating with them, and was fortunate to be able to bring some devices on board last year during Coastal China, and also this year on board on the Atlas and also MB Independence. And right now, the devices we have are the Android devices that's commercially available for continued multi-factor authentication to collect different biometric information, including the gate and the way how you're typing, and also the device's GPS location, and how you interact with the device itself with the panel capture the data in addition to the visual, if you want to set it up, or voice recognition and the fingerprints. And they calculate a trust score. So when the score is high, then the more accessibility is available to get into the network or server. If it's a low score, then it continues to check, and then maybe getting logged off if the score is not high enough to access certain area. And this would be similar to a CAD card that we right now have that access the government facilities or access the computing system like MNCI machine or government. But they will also enable the login through the PKI, public key infrastructure, and through the device itself, you can access to the system using this as a purebred that create the key certificate. So instead of need a CAD card, then the mobile device can serve as that purpose as well. The other thing is that they use the hardware attestant that there is a Snapdragon chip that's been designed and made available from the vendor that's going maybe next few years going larger production for the embedded that hardware attested key information that's being worked there. And the other system that we have is the backpack safe case for iOS system. A lot of government, 90% of government cell phone devices are iOS system. So that add an extra layer of protection that actually can detect if the camera is being used, if the phone call is being enabled, if the device is in secure space, they're not allowed to do that, then it's going to be create alert, and the server or central database will know that the rules or policies has been violated. And this project, they are going to move to including more stakeholders, including Department of Energy, and Air Force is going to heavily participating in the next coming, I think next month or so, and with several private companies engaged as well. And they are expanding not only to iOS system, but also to the Android device as needed. It's going to be a upcoming 4-year project that as of this week, they just told me that these are being updated. The other thing that is upcoming is also the smartwatch. As you see on the video, that the watch itself as a wearable can be a standalone or integrated to the phone system and to the computer network system to be able to authenticate and identify, have multi-factor authentication, continuous multi-factor authentication as well. And for these systems, these are designed then on the land-based system. So we at Navy has a different work environment for the ships. That's why we are trying to get this testing of evaluation and use feedback to this for the ship environment to see how this can help our sailors and our warfare fighters and enable the capability and improve the ability for security and on board the ship, and also to be able to provide the enterprise solution for DoD-wide, and not only just the land-based, but also maybe ship-based or maybe on the airplane. So different scenario running through these. And I think I also want to mention that we also had some work with vendors on the social distance app that we had the 4 devices to watches to cell phones that trying to detect and see how the system works when right now it's very timing for this COVID social distance, that when we are returning to workspace and returning to how do we track the physical distance, and this is one of the prototype we have to get some evaluation on board on the Coastal Trident as well. I think that's the brief information I have, but I have the test result, some of the data, someday maybe can show, but right now it's not cleared for publication or for the Public Affairs Office. So it's the map that the device that can be tracked, and then the data that's being collected, that's being used to generate some of the algorithm actually is artificial intelligence based. So the more data they get, the more accurate it can reflect the individual's user behavior or biometrics data to be able to authenticate correctly and quickly.
Excellent. Thank you, Li Ping. We do have one question in the chat, and it says, how does the solution handle networks or communications down scenarios?
So some of them that they have the local storage, like one of the multi-factor authentication is called a 2Sense app. This one, they communicate with the cloud periodically. So I actually want to have like at least once a week connecting to the Wi-Fi so that the data can be transmitted faster. And so there is a local storage, and also for the Bluetooth or near field communication that can be communicated between the devices, like for the social distance app and proximate tracking. It's mostly depend on the Bluetooth between the devices that it can sense 6 feet fewer.
Gotcha. Thank you so much. Okay, well, thank you, Li Ping. I really appreciate you being here, telling us about that project. Looking forward to how we take it forward for Coastal Trident 2021.
Thank you, Brandon. I appreciate.
All right, next up, we've got John Carter from IXI Electronic Warfare. And he's going to tell you about one of the Counter-UAS systems that we experimented with his organization. This is module 4.2A, Point Defense Systems for Countering Unmanned Aircraft. John, take it away.
Okay, thanks, Brendan. Hi, everybody. My name is John Carter with IXI-EW. We are a Counter-UAS company based in Orange County, California, and we have developed a product called Drone Killer. Here it is right here. It is a handheld Counter-UAS device. It's 9.5 pounds. Alan, can you go to slide number 2, please? Here's our quad chart on it. It's a 7-channel jammer. It takes care of 433, 915 megahertz, 2.4, 5.2, 5.8 gigahertz. And then we have the options for L1 and L2 GPS. Currently, this drone killer is fielded by the National Security Guard in India. They are called the Black Cats. They protect the Prime Minister. The Royal Thai Air Force also has a few. We just got a PO for the US Air Force, which is exciting. We've been trying to break in with our DoD for a couple years now, so this is a good victory for IXI-EW. And then as far as local law enforcement, LA County Sheriff and then also Las Vegas Fire and Rescue have a couple units that they deploy to protect the Strip. LA County Sheriff uses them at baseball and football games, any red carpet event. So with the drone killer, it's pretty simple to use. Power the button on right here, turns on, and it's a point and shoot. So like I said, 7 channels. Currently this unit right here, when you pull the trigger, it shoots out those 5, the 433, 915, 24, 5258. And then it also has a separate button for the GPS. The next version that we're coming out with in a few months will actually have a target analyzer board. So it will be able to sniff for the RF from the drone, and it will determine what frequency is out there. So when you pull the trigger, it will only emit that 1 or 2 frequencies that are in that 30-degree cone. The battery's lithium ion. It is 2 hours continuous trigger pull, and it's good for 6 hours in standby mode, under 10 pounds. Let's see, what else? Can we go to the next slide? We have a little presentation here. This is just coming off of some of the threats that are out there. Most of the threats come from DJI. And there's also some, I would say, surveillance drones that come from some other companies. But the main threat that we see out there, DJI has about 70% of the UAS market. So Drone Killer is, it's targeted towards drone, the waveforms in it are drone specific. So when it comes to collateral damage, when you pull the trigger, you won't affect cellular communications, you won't drop Wi-Fi. The only thing that it does affect is Bluetooth. Super hard to not affect Bluetooth. Next slide. This goes into more of the specs that were on that quad chart. We can skip this one. What we do here at IXI is we have an anechoic chamber downstairs that we scan all of the drones. We figure out how they're not only channel hopping, but also frequency hopping. And then that allows us to write the defeating algorithm. What we're doing is we're simulating the signal that is going from the control to the drone, which confuses the drone and it forces it into its fail-safe mode. So whatever the pre-programmed, if it's return to home, hover, or land, we force the drone into that mode. Next slide. Here's just kind of how we can characterize the drones. This is showing, I think this is the Mavic in 2.4. You can see the different channels that it will basically go from one channel to another. So that's how we determine how we write our defeating algorithms to basically scan the frequency quicker than the drone is. So when it sees that interference and it looks for a new channel, we are already on that channel, so it has nowhere to go. Next slide. So there's two different types of jammers kind of when it comes to Counter-UAS, kind of classified as like a barrage jammer. A lot of our competitors just put out a lot of noise and block the whole frequency. What Drone Killer does is it uses a smart jamming technique. So with that, we're not affecting any other cellular communications. Next slide. Here is one of actually the older control panel that we had. It's a little bit different now. Let me see if I can get you guys a view of that. There's power, GPS. We have a long and short range. So if you have a detection system and you know that drone is coming from a longer distance, you can hit the long button and it'll focus more to hit anything at a longer distance. Next slide. The battery. This is a proprietary battery that we made. It is lithium ion. Our next generation that we do will have a mil standard battery, which will make things a lot easier. One of the things about this unit, it's a software defined radio. So if we do see a new threat, or let's say DJI changes their waveforms and they're no longer in the current band, we can write that defeating algorithm and then push that updated waveform to the end user in this port down here. Next slide. Here's some of the events that we've participated in. We tested with the Marines a couple years back at Camp Pendleton. We also did a NATO non-lethal back east in 2018. And like I said, it's used to protect the Strip. The United States Bomb Tech Association is trying to help us right now, try to push down the authority for local law enforcement, particularly bomb squads, since they already use electronic countermeasure, to be able to use this, to put this in their kit. It's also is used at some of the riots here in California during 2020. And Brendan, I think that's it.
All right, I think I'm off mute. Thanks, John. Really appreciate you guys coming out with us yesterday on the Indy. We've been working with the IXI team, with Drone Killer and the predecessor company, Icarus Technologies, since the system was ready for market. So we've seen this system come through quite a few different iterations in its internal workings. It's always looked the same relatively on the exterior, but dramatic increases in capability. So that's been really neat to watch. This was the first opportunity that we had the system out on a ship. So really neat for IXI to be able to answer that question that, you know, not just in theory does it work on ship, but it works for real. We tried it. And, you know, for any of the organizations looking for a counter drone capability, we found it tremendously easy to use, pretty foolproof, very effective against everything we've flown against it. I think the only thing that we have ever flown against your system that hasn't been able to take down was a UHF or VHF controlled RC plane, and I think we kind of cheated on that one. So sorry about that, John.
That's all right.
But yeah, I mean, I can vouch for the fact we were on push to talk radios while you guys were jamming, and I was talking to Alan on the shore. So very good system. Really pleasure to work with you guys. Can't wait to see what we're going to do next. Okay, I believe next, I don't see any questions for John in the chat. So if any come up, we'll be able to address them. Or we can, John, if you've got to get off the line for any reason, we can just we can forward them to you by email if they come in.
Okay.
All right, thank you, John. Next up, we've got Dr. Jean Pan with NAVFAC's Engineering and Expeditionary Warfare Center. Her project, we've been working with her for several years on using unmanned aircraft to conduct aerial surveys for a number of different applications. And that is module, let me find it, 3.3 Bravo. So unmanned survey for digital engineering and infrastructure assessment. Dr. Pan, please take it away.
Hi, Helen, thanks. I had unmuted myself, I thought, but I did not. Okay, so can you, just to verify, can you guys hear me?
Yep, Jean, we hear you loud and clear.
Okay, great, thank you, sorry about that. So thanks, Alan and Brendan, for offering the opportunity to present the current status of this project. It has been a while. This has been like, I think, 2 to 3 years, and with Alan longer than that. So first, I'd like to acknowledge all of the collaborators on this project. We've been working on using UAS for turn monitoring since 2016, and we've been through a lot of challenges together, and we wouldn't be where we are without everyone's contribution. So we have a number of collaborators that's from NIWC who are working on the machine learning part. Alan was integral in getting us started on the UAS portion of the monitoring, and then Todd Van Epps at Ventura County of Education followed up with that and was super helpful. And then we've also been working with Martin Nguyen from the Navy base, MBVC, on doing the monitoring and using his turn colonies. So slide 2. So this project started out because we really wanted to determine if UAS could be used for natural resources monitoring. So there are a number of reasons why UAS was really suitable for resource monitoring, and as we delved more into the use of it, this led us to develop a machine learning approach for UAS data. So with the UAS, we were interested in being able to regularly access resources that we were monitoring and improving our situational awareness of those resources for adaptive management. For a lot of the resources we look at, you can't always view them all the time. There's usually certain periods of time where we can actually access them without disturbing them. And so that means there's a lot of gaps in time where we can't see them. And the use of UAS allows us to have a view of these resources without disturbing them quite as much as, say, having a person go into an area or looking at the resource. The UAS technology has broad application for monitoring and can be applied to a variety of resources and species. So even though we're working on terns, we envision it can be used for other bird species. We're also looking at it for one of the projects that are coming up is possibly using it for mosquitoes, and vegetation is also an area that we've been looking into as well. So for our system, the California least terns, we really wanted to reduce the disturbance to the birds and be able to continue collecting data throughout the nesting season, especially when there are chicks and fledglings around and you don't want to disturb those life stages because they're more vulnerable to disturbance. They can't fly, and so their only recourse is really to run away. So they tend to be more, the stress level tends to be higher for those stages. On slide 3, our initial goal with demonstrating UAS for California least term monitoring was to determine whether we could actually fly over the colony without disturbing the birds, and see whether if we could see the birds and the different life stages using the UAS. So given technology and our flight limitations. So we conducted this part of the project in 2017 and 2019. So this is a review of our results from there. And NBVC had provided ground truthing. So when we find something, they also have, since they're walking through the colonies, they also have information on what's actually out there, so we could compare that data. Okay. So on slide 4, this is to show that we could fly over the colonies without flushing or disturbing the birds, and that was a huge, I think, win. It was kind of very surprising as well, but they didn't seem to mind us, and we did develop an altitude that it was safe to fly at. So this slide represents an image that's typical of what we got from the UAS. And in order to look for the birds, we went through each image one by one manually to look for different life stages of the least terns. And on the next slide, you can see that we were able to see a variety of least term life stages. So we had, you can see adults there, they're doing various activities. So it's kind of interesting that they were not affected by us flying over, that their behavior actually didn't change. Okay, and then you can also see the upper right there. There's that brown blob is a fairly young fledgling, so it's older than a tiny chick, but early stage fledgling. And we can see eggs in one of the images on the lower left, and then the lower right, you can see fledglings. Those are older fledglings, and you can see that they're gray, kind of similar to the parent, which is in the upper left there. Okay. Okay. So as you can imagine, so next slide, please. As you can imagine from the first image that I showed you, trying to find the least terns in these images can be quite challenging, especially if you have pretty sparse nesting colony. And unfortunately, that's been our experience in the years that we've been able to fly, as the nesting colonies have been not as robust as in some years. But even in years where we don't have, a huge number of nests, you still have to fly the whole area in order to find the nest. So here are some data collection numbers on this slide, just to give you an idea of the amount of data that we collected during this demonstration, and that someone actually needs to go through and look at to get the important information. And I think that really to effectively use UAS for monitoring for any natural resource, not just terns, we need to have a more efficient approach of identifying our targets, or identifying and getting the information that we need. Otherwise, people aren't going to want to use it. Okay. So next slide, please. So we ended up teaming up with another warfare center to use machine learning for target object identification, specifically terns in this imagery. Because we really weren't sure whether it would be possible to identify such a small object. These terns are about 8 to 9 inches. And it's a pretty tough problem given the sort of generic and very homogeneous background they're in. I mean, there's some topography, but it's pretty much sand, sticks, and vegetation. So sort of given those parameters, we decided to focus on the adult birds because they are the largest target. Everything else is smaller than that. We also had the most data for this group. So in order to be able to train the model, it's critical to have a certain amount of, the needed amount of data to make the algorithm work. And for most of the other stages, we ended up not having the same amount of data as we had for the adult birds. So we used the data collected from 2017 to train and test the algorithm and got results that were better than expected. We had an 84% detection rate of adult birds, and that's for them in various postures. So that includes like flying and sitting. And we also had about 95% accuracy for the identification of birds. So, and given our current computer systems, it takes about 45 seconds for the image to scan, or for the computer to scan an image. It's way faster than a person can do it, but it's not particularly fast when you think about thousands of images. So that's something that we'll be evaluating and working on to try to get that working a little bit faster. But so while the algorithm performed pretty well, and so we're on slide 7 now. We still need a way for a person to verify the results of the putative ID. I mean, there's, even at 84%, it's still missing quite a few. And so we want to make sure that we can capture as many terms as we can. So we're actually willing to accept a higher false positive rate and then have a person go through and look at the putative identifications and verify whether they're correct. So in the next few slides, slide 7 and on, I wanted to show you what our current user interface looks like and examples of target object identification using our current user interface and what is being identified. So on this slide, you can see on the upper left side, that's basically the image that we're looking at, and then any putative target that's going to be evaluated is going to be, well, that slide's going to have all the putative targets on there. And then you're going to the human would then evaluate each of the putative targets to see if they're real targets. And so you can see here on the window on the right, this is basically a blow up of the square on the left side. And so this is the object that the algorithm has identified as being a potential turn. And so if the object is not a target, what you would do is then you'd hit clear and the next putative target would pop up on the screen. In this case, we go to the next object because there's only one that was identified. If the object is a target, then we get a pop-up box that asks us to verify the details of the target, which is shown on the next slide. And so you can see here on this slide, there's a box that pops up, and then we can mark the object so you can actually provide further information on it. And we can see here, you can put in the life stage, what behavior it's exhibiting, and in this case, for this particular object, it's an adult turn, and it looks to be incubating eggs, and so we would mark incubating eggs. And at the very least, the turn is sitting, even if we can't see what's beneath it. So although there are some subtle differences between sitting and incubating eggs. But once we get all these attributes correct, we can hit OK and then go on to the next image or the next putative target within that image. Okay, let's see. Next slide, please. So here's another example of a slide with targets identified on the left. And so you can see the close-up of the one in the middle is on the right side. And this is an example of what we're seeing as false positives, which I think is kind of interesting to see what the algorithm is identifying as false positives. And this one, you can kind of, if you squint hard enough, you can maybe understand why the algorithm has picked it. Because it is like a black, it does have a black blob or black head, what looks like to be a black head, and it's sitting on gray. But because it's not a target, we would go ahead and then just clear the box and then go on to the next one. So that way, we have, as we're doing this, we also end up having a better label data set that can then continue to train the algorithm. Okay, and on the next slide, we have a couple more examples of false positives. Here's what the algorithm thought. The algorithm thought that the feather on the left and the plastic water bottle on the right were both targets. And interestingly, I didn't quite understand why it would choose a water bottle. It's obviously has some kind of different stuff. But when we were looking at some of the images this year, and at certain angles, actually, a water bottle can kind of look like a turn. It's and I suspect what's going on is that the hole around the cap of the water bottle looks like a black blob, and then the rest of the water bottle itself actually is fairly gray looking, so it could look like a bottle. But we're continuing to use data to refine our training of the algorithm so that we can hopefully not get these types of false positives. The challenge with the machine learning algorithms is that when we're really not sure what the algorithm is picking up, and when it identifies, like how it identifies an object, so it's very difficult to actually correct it. So next slide, please. Okay. Sorry. Oops, sorry, I'm going a little over here. Okay, so interestingly, this algorithm, even though it was trained on adults, it was actually able to identify some fledglings. And you can see the fledgling on the right here. It doesn't really, it has the same body shape as the adult, but the coloring is quite different than the adult. It doesn't have that distinct black head on the, like the adults have. So not really sure what it's focusing in on, but we were able to actually, it was able to stretch itself, so to speak, to identify objects that didn't look exactly like the parents. One drawback of our current algorithm is that it is a little bit inconsistent. It doesn't always pick up the same bird in all the images it appears in, and that happened for both the adults and juveniles. So while the targets and successive objects were obvious to human observers, it was less so for the algorithm. And that's probably because the angle of the object changed as the UAS flew over it. Okay. So areas that future work that we're still working on, we really are, the primary goal this year is to transition this object identification and the user interface. Sorry, we're on slide 12 now. To field practitioners, so people who are actually doing UAS, or no, sorry, California lease turn monitoring in the field. So we're working toward that goal at this point. We're also continuing to train the algorithm with additional data from 2019, and then we'll test it against the data that we collected this year to evaluate how it does. And we actually had new locations and different imagery qualities, so it will be a challenge for, it'll be a challenge for the algorithm. We also hope to identify other more challenging life stages. I think we should be able to get fledglings. As you saw, we're doing a somewhat decent job by unexpectedly to get fledglings, but like eggs and chicks, I think, are going to be are unlikely to. We're probably not likely to get those very easily. We also want to improve the speed and accuracy of the algorithm, and we're evaluating a few paths for these, like including hardware upgrades, using GPUs, and further refining our algorithm as well. And the next thing we'll be working on, I think this is the next big push, is looking at transfer learning of the algorithm. So using this algorithm and seeing if we can identify other target objects. Okay. So next slide, please. I just like a few more acknowledgments. These are a variety of high school students and interns that have been instrumental in helping us, make so much progress on this project. And, for example, the two VCOE students in the lower right-hand corner, they were up at like 5 a.m. at, Point Mugu to do our flights. So, which is pretty unusual for teenagers, but they did a great job and they were awesome. Okay. So that's the end of my presentation, and I'd be happy to take any questions. Thank you.
Thanks, Dr. Pan. Appreciate you joining us. I know you've got a tight meeting with the Port of Hueneme to talk about when you're going to fly at the port this weekend. So I don't see any questions about your project in the chat right now. So if there are any follow-on questions, I can definitely forward those to you.
Thank you.
Thank you. Have a great day.
Okay, you too. Thanks.
All right. Moving on. So if you look at the agenda, we are a little bit behind, but our last event is just kind of the opportunity for everybody to figure out how they can connect to the people they want to connect with. So after we get the last presentation, then we'll kind of leave it open for you to exchange contact information, for you to continue using the chat. Everybody's really engaged on that. We really appreciate that. Or we can break out companies into breakout rooms, and they can have conversations with folks who are interested. So you kind of need to tell us what you want to do in that respect. And we'll facilitate it to the best of our ability. So our final presentation today is Mr. Rob Ratcliffe from Future Tech. And he's got a couple of projects that he's going to talk about. One is Module 3.5, which is the tethered aerial relay. And one is Module 3.2 Charlie, which is autonomous launch and recovery of unmanned aircraft. Rob, go ahead and get started.
Can you see me or can you hear me?
We can hear you now.
Okay. Hey, thanks, Brendan. I'm Rob Ratcliffe. I have a small consulting practice that's mostly focused on U.S. military applications, drones and signals intelligence using the Raptor X framework. I'm going to talk to you today about a couple of capabilities. I was going to demo on the Independence this year, but because of the travel restrictions, I couldn't do that. I graduated from A&M. In aerospace engineering in the 80s during the Jackie Sherrill days, where we actually went to started work at Boeing designing wings and airfoils. Let's see. And then switched over to consulting 95 or so and developing military related applications for about 20 years and drone applications for the last 7 years. Let's see, okay. And then, so my little consulting company, we support a few plugins in Raptor X, which is a government GIS platform that supports plugins. Station software that I'm going to demo later today.
Hey Rob, this is Alan.
Yeah.
Can you hear me? We're kind of losing your audio. It sounds like it's kind of coming and going. I'm not sure if you're on a headset, maybe move the microphone a little bit closer. And then your presentation must like auto next. So I'm just doing it in mode like this. Just let me know when you want to go, but hopefully we can get your audio a little better.
Okay, is this better or?
Yeah, sounds like it right now, yeah.
Okay. Yeah, so we support a few plugins, Raptor X, DPAX, which is the one we'll talk about today, and then Sandbar, which is RF link analysis, which I support. There's a couple. You can go to the next slide.
Hey, Rob, we're still having a hard time hearing you on this end. I don't know if however anyone else is having issues, but you're coming and going.
Okay.
You have another way to, I don't know how you're dialing in, but you're kind of fading in and out.
Okay. Let me see here. Let's see if there's a way to. Is that better or?
Yeah, we'll give that a shot.
Okay. All right. So yeah, here's just sampling the projects that I've developed over the years. At Boeing, I worked on the F-16XL laminar flow wing, and then in this NB-Opt, there's a distributed multidisciplinary optimization system. And then recently I've been working with the DPAX and Touchstone and the Sandbar plugins using Raptor X. The next slide, please. So DPAX is this command and control plugin for Raptor X that was commissioned by Michael Clark, and he's on the call now. He wanted something that was make it easy for a new pilot to fly a drone. He evolved into supporting multiple missions and static and untethered flights that Jim Harvey supported. And I added some initial support for rovers and airplanes this year. The main design goal was to minimize drone pilot training and to provide mission oriented leverage the Raptor X infrastructure and other plugins to do multi-int tasks. Okay. Yeah, so this is the fleet of drones that we've flown with DPAX over the years. A lot of them are my test drones. So I end up crashing my own drones before we test on the more expensive drones, out in the field. So most of these are just my test drones here in Austin. And then we have the TMRS and TMRS-2 drones that are waterproof drones that will be tested out in Camp Roberts and are going to. And then this NTP drone, which Clark is working with, is a waterproof drone, and it can carry some significant payloads. He has 2 sizes there that he's working with. So we hope to maybe demonstrate those next year, you know, if everything comes together. Next slide, please. So I've been working with these guys since 2017. Brian Hill got me involved originally, so because he was working with Reese and it was integrated with Raptor X, and he wanted to be able to task drones automatically, you know, based on the target that he was acquiring. And so we did a couple years of that, and my original implementation for landing used a M8P RTK, which it took a long time to get a fix. It could take 2 or 3 minutes to get an RTK fix, and the ship environment was hard to get the fix, and so it just didn't work that well. So in 2019, I went out again and brought this new generation RTK, which is a F9P from uBlocks, and I did a deck-based evaluation of that, and that was much more successful. And you go to the next slide, please. So basically, I got to tag along on one of the trips on the Independence, and then I just did some testing out on the deck of the boat to see how fast we can get a fix, and you know how it responded to the 30-foot you know, command or the cab that it has, and it did much better. And the only adverse effect I saw was the deck temperatures, like over 100 degrees, ended up having an effect on the quality of the fixes. But otherwise, it did really well. And just to let you know, the benefit of the RTK is you can get like a 2 centimeter accurate vertical and horizontal position with it. And with the F9P, it also supports multiple constellations, you know, GLONASS, Galileo, GPS, L1, L2, and BIDO and SBAS. I mean, it's a pretty capable GPS, and it supported this moving baseline mode, which was useful for cases like the ship case, where you have the base RTK mounted to the ship, and then you have the another RTK mounted to the drone, and you're getting a differential solution between the two, but the base is moving continuously. And the M8P didn't work that well for moving base, and so I had to use some kind of pseudo moving base mode that, you know, had a lot of issues. So I guess that's, you know, another nice thing about the GPS solution is it's independent of weather and you know, night or day flying, and you know, independent of the terrain that you're under, so you can get, you know, good accurate altitudes because it's 2 centimeter accurate, so you don't have to worry about drift of the barometer and that kind of thing, or using a LiDAR on the ocean or you know, over trees, or you know, that kind of thing. So there's some benefits to it. You know, the negative is that if it doesn't respond, I mean, if you have a jamming situation or, you know, GPS denied situation or spoofing, then there's that weakness it has. But otherwise, I think it's a pretty good solution. Next slide. So for Coastal Trident this year, so I was going to try to use the F9P RTK off the boat to see, you know, if it performed better than the M8P did a couple years ago, and then see if we can do, you know, fully automated precision landing on the boat. And then another thing was to just demonstrate how a tethered multi-rotor could be used as a relay. So we were going to use like you know, more of the production quality radios, like a wave relay or Silvus, but for an Austin test, I just went ahead and grabbed these RFD900X radios that supported a multi-point relay approach, and so I use that to mimic using a tethered drone to get a better line of sight to a remote drone. And then I was going to demonstrate the use of DPACs for controlling drones in these different scenarios. And I was going to demonstrate the precision landing using IR-lock and a infrared beacon, just as a GPS denied approach. But I was having some technical issues and it was taking me too long to debug it this last week. So I have it all configured. It's just a matter of getting it to work. But I have to work. It's going to take a while for me to figure out why it's not working. So anyway, I abandoned that since I had enough to do with the other scenarios. So next slide, please. So this is what I came up with to mimic the boat scenario. We came up with this rover RC car and towing a sled, and then it's there's a board in between it to keep the distance the same. So this would mimic a boat with a landing deck, or a truck with a bed in the back. So it's a fixed fixed distance back from the truck. And then I used just to clean up the connections, I used a Raspberry Pi to connect to the GPS and the PICSOC, the serial connections, and then streamed it through Wi-Fi to the laptop. And then the laptop then communicated with the RFD900X radio that was also on the drone that was following the truck. So this mimicked, what we would have done at off the ship, and then it also the communication through TCP/IP with the ground station is similar to what is being done on the production systems that like Clark is using and the TMRS systems are using. So there's a better architecture for mimicking what would be fielded. Next slide. And then the relay network was basically using RFD900 radios on the laptop, and then there was a separate relay RFD900 radio that was configured for as just a relay, and then the laptop then communicated. I had two laptops actually, one for the tethered drone, the hexacopter, and then another laptop that was communicating with the remote drone. And then the remote drone actually was, I didn't fly the remote drone, I just put it on the top of my car and drove it around while my son monitored the tethered drone and let me know, if he had any questions or if something was going wrong or whatever, I can tell him what to do. And then, if I lost link, then I could tell him to raise the drone another 10 meters and see if I could regain link as I drove around the hills and valleys in the area over by the RC park. Next slide, please. And then this is what the iris looked like with the rangefinder and the Pixie camera. And so, well, I should get that working in the next week or two, but it just wasn't working. So I abandoned that, but just want to let you know, want you guys to see what that looked like. So next slide, okay, let's go to the movie then. Okay, so I'm going to demonstrate two of the capabilities I just talked about. One is the follow me with precision landing, and the other one was the relay network. And we were virtually demonstrating this in Port Hueneme. Our mock ocean was Lester Field, which is a radio controlled field that's out in Austin. Pretty nice facility, has a runway and everything, and a nice giant fields for flying. Here's my mock Indy, and then the drone that will have the follow me drone with the F9P RTK and the RFD900X radio, and there was the Iris. And here's what the RFD900 radio looks like. And then this is the this scenario. So everything's being controlled by DPAX, and so the flying of the drone was all automated. And it was basically, and then I had my son, recruited him as the RC truck pilot, and so he would drive the truck around, and then I would monitor the flying of the drone to make sure it was following correctly and that kind of thing. But basically, it was autonomous from takeoff. It was autonomously following the drone around using the RTK GPS positioning. And then I just had him drive around as fast as he could, you know, and had the drone follow it. And then I had him stop because at the very last half a meter of landing is just uses the regular land mode, so the motors turn off. So that way it would hit the target. So that in that case there, it hit the target right exactly. Then here's how it looks within DPAX. It is arm, and then launch, and then as soon as I launch, it starts following the rover. If it's connected, it automatically determines whether there's a rover or not, and then if there is a GCS or rover, then it'll automatically switch to follow me mode and start following the rover around. And I switched over here to an RTK offset based approach for landing to get the more precise landing. And then I used instead of using a normal RTL, I use a guided RTL where it sends waypoints at precise locations and then lowers the altitude to get it closer to the landing platform. And at the last half meter, it switches to landing so that the motors stop. And then we also tested just, you know, how does it look a takeoff while moving. So it actually worked and it didn't crash. There's some work to do there to finesse that, you know, for a faster moving platform if you're trying to take off while it's moving. All right, some of the applications of this for a Trident Coastal or a Coastal Trident is aerial surveys, you know, automatic takeoff and landing, and then the Reese scenario where you want to verify a target that's been acquired and you want to automatically take off and then go look at the target and then land, or maybe even package deliveries between ships, or there's a lot of capability, you know, a lot of benefits to doing an automatic takeoff and landing scenario. So the next scenario was RF line of sight improvements, but with a tethered drone. We started off with a 10-meter height, and then used the scenario that I talked about. This architecture where we used a hexacopter to get better line of sight with a low flying drone. This is my poor man's waterproof drone there, and that's the one that was on top of the Suburban. So I drove around the area there on the roads, and there's a bunch of valleys and hills in that area. So I would lose link, and then so I would tell my son to raise the copter another 10 meters until I would regain link. And then you know, sometimes the drone actually went into failsafe because he was underneath a metal roof, and when it got high enough that we lost telemetry. And so anyway, I had to kind of talk him through that on the phone, but he got it, and he was able to recover and have the drone take off again, or halt the landing process. But here's some sandbar results where we just where I showed link in the area based on the altitude of the drone. The red is no link to the radios, and then green is link. So in summary, you know, for a Trident, coastal Trident application, I mean, just having a tethered drone allows you to get quick improvement in comms, because with better line of sight. If you were in a distress situation, you could even deploy a drone and deploy a beacon up at high, or you know, that kind of thing. Here's my RC operator and my GPAX operator that I recruited, and then we had a little bit of fun at the park as well. And he got pretty good at driving the RC car around. So I want to thank my sponsors, you know, for Michael Clark, he's online right now, and he's the driving force behind DPAX, and he pioneered the use of tethered drones in various ways to power and communicate drones, the data to the drone. He's also a great filmmaker, and he helped me out with this video, and worked together since 2013 and made a great team. And Jim Harvey at NSW, he manages the TMRS systems, and he funded a lot of the evolution of the drone, of DPAX for other scenarios like the Follow Me mission and that kind of thing. And then also I'd like to thank Brendan and Alan for all the support over the years. Even though I'm a small player, we've you know, they've always welcomed me out to the Trident Coastal Trident exercise, and you know, we've had a lot of adventures over the years on the Independence, and all those have been very valuable in improving the operational capability of the software. So yeah, I guess that's about it. Next year I hope to, you know, validate the processes off a boat with production quality waterproof drones and military grade radios, and continue to improve the precision landing process, and maybe even test out how the F9P does against GPS jamming and spoofing, and then come up with, you know, mitigations for those cases. So that's all I have.
All right, thanks, Rob. Really appreciate you. I was texting with Alan, and we both agree that you and the Teledyne and MarTech team definitely get the award for embracing the remote and virtual concept for Coastal Trident. We really appreciate you, you know, doing what you do and learning all the things you're learning, and willing to adjust and be flexible to share all your information and your knowledge with us. So looking forward to getting back out on the Indy and having some adventures, some more adventures, and seeing what you're doing. We do have a couple of questions in the chat. One says, are there any plans to test with a Lockheed Martin Indigo or the FLIR Skyraider?
I haven't talked to them. I've seen those systems, but I'm not in contact with them, but you know, we could, so.
Okay, so that question is from Richard Grays. If you've got the ability to make a connection, reach out to Rob, and he's definitely willing to work with you. Comment from Joel Young: expect GPS jamming in a contested environment where it's close to the tactical edge. I think, you know, that's the whole point of your RTK and IR beacon experiment, is to see, you know, what the alternatives are for precision landing in the absence of GPS. So,
right.
You want to talk about that anymore? Anything else to add?
Well, yeah, one thing I wanted to test out is just with these multi-constellation GPSs, where the frequencies are different between the GPSs, you know, could you switch to the GLONASS, you know, network, or the Galileo network, or the BIDO network, or something like that? If US GPS was jammed, you know, could you automatically switch over? I don't know how broadband the jammers are. So I don't know if it wouldn't seem like they'd want to jam themselves, you know, like if you know, GLONASS or BIDO or whatever. So anyway, I was thinking that might be a way to mitigate some jamming by switching over to another network, another constellation. But that's just a theory.
Okay. Well,
yeah, I mean,
let's get out on the Indy with a jammer and test it out.
Yeah. Yeah. Right.
All right, and then the final question from Jennifer Elliott is, what is the length of the Austin runway, and is it operational or used frequently?
Well, the one at the RC park it's probably like 100 meters. and they use that for, use RC planes and larger drones. The university goes out there a lot and flies, larger drones, and there's some other R&D companies here in town that are flying some pretty large drones, and so they fly out there. But yeah, it's operational from a RC perspective. It's pretty nice. Yeah, it's pretty nice area. I'm just hoping property taxes don't kill them at some point. Make them abandon it.
All right, Rob. Well, that's all we got in the chat. If there are any other follow-on questions, we'll definitely forward them to you. Thanks for being here.
Okay, thank you for letting me participate.
Yeah, absolutely. Okay, so that's the end of our second track, kind of summarizing a few key projects that we have for Coastal Trident 2020 and ANTX Coastal Trident. I'm going to kick it back to Alan. He's going to kind of close us out for the day, but explain kind of how the rest of the time that we have allotted for today is going to work, how we're going to make connections if you want to make them, and then kind of give us a preview of what's going to go on tomorrow.
Okay, sounds good. Thank you, Brendan. Yeah, so we kind of weren't sure exactly how to do this. We wanted to provide a venue and an opportunity for folks to connect if they want to. The chat's been used. There's been a lot of contact information going back and forth, I know just privately between folks as well as being shared. So that's great. We want to help do that. If people want to use a breakout room or something like that, we're happy to facilitate that. Again, just let us know. Probably the best bet is just put a message in to the chat under FathomWorks, and Haley here will connect you guys up. But feel free to reach out directly. Like I said, if there's something we can do on this side, it's really just an open time. Normally this would be when we're kind of wandering through the tables and seeing the demos and helping facilitate those connections. We can't do that now, so this is how we're doing that. So we'll stay online for a while until we see how things work out. As far as the agenda for tomorrow, tomorrow's our third and final day. We are going to kind of be focused on kind of the way forward, community engagement, some additional opportunities. So we're going to hear from some of our strategic partners. We'll kick it off in the morning with Mr. Bruce Stensley from the Economic Development Consortium, followed by Chief Operations Officer Christina Birdsey from the Port of Hueneme. We'll hear some remarks from Gene Fisher from RDP 21, again, all focused on kind of the partnerships, outside of the Navy and how they work and how we can facilitate this idea of, the funnel of sourcing, curating, finding, prototyping, experimenting, and ultimately deploying capabilities. And then we're going to kind of break off into a couple different breakout sessions. A couple of them have changed, so we're going to kind of play it real time tomorrow as far as what the topics are. We'll have Mr. Greg DeVogel, who's our Chief Technology Officer. He's got a presentation on kind of where we're going as a Surface Warfare Center when it relates to in-service engineering of the future and some of the technologies that we're really focused on. And he's responsible for managing our research budget and our research priorities. So that would be some good insight as far as where are we going here locally. And then, again, we have the Matter Labs guys talking about some SBIR opportunities, funding opportunities, some good breakout sessions. So hope you're able to join us tomorrow. We'll kick off again at 9 a.m. Haley will send out a link in the morning if you don't have it from the original one, and kind of the same format. So with that, a big thank you to everyone for sticking with us. Hopefully it was a valuable day. If there's any questions, hit us up. Like I said, we're here to help facilitate the connections or answer any questions. With that, Brendan, I'll pause and we'll just see if there's anything we need to do. And if you're done for the day, thanks for joining us, and we'll see you guys tomorrow.